Hey, Stookie. How's it going? Just trying to troubleshoot an issue with the YouTube stream right now. I'm hoping it's just a simple stop and restart, but I guess we'll find out. Good day, Tranquil. That's good to hear. All right, so far stream is okay. Let's, I guess, keep looking for questions while we wait to see if YouTube melts down again. Hoo-hoo, hey! my niece, I guess. How are you? Oh, dude, that works on two levels because you're French and there's a place in France named Nice, right? So, okay, here's one without an answer. I am good. Oh no, the lighting was so good when I started the stream and the clouds are blocking the sun now. I think I'm gonna let it roll though, it's not that bad. You dye your hair again? Oh, cool. What color? So I guess you would divide each side by V and to make this a little bit easier. dP by dV equals minus nRT over 2 or over V. I assume they mean squared. And so I like that. Will be inversely proportional to the square of the total volume, I think. You think it's red? Oh, nice, nice. Going for the fun colors. And then you need the partial with capital R and with little n. I guess you just drop the R and the n as the effect of that, and you have T over V. Whoa. Oh, what? What? Oh wait, oh, it's dt. Okay. So I guess you'd divide by nr and then do the same kind of procedure. So it'd be minus pv over... Shouldn't it be... No, now it'll flip to positive. It'll be n squared r squared on the bottom. Saying r is a constant. I don't know if I'm following that. So, Jed, you got first? You're last. A better interpretation might be to say it's inversely proportional to the square of the total volume. The second one, not sure I understand the partial you got. Like, so to explain that, like r is a physical constant. Why would you take the partial in terms of a constant in the first place? That is weird. So this has surely been done before, right? Partial derivative. What is this called? Like ideal gas equation? Ideal gas law. Hey, Ali. I don't know how to pronounce that last part, so I'm just gonna call you Ali. How's it going? Didn't we just do dp by dt? Oh, they're talking about like the difference between a partial and a not partial derivative. I know what the opposite of a partial is. How to become good at math with having a degree? I'm gonna ask for a bit of clarification, Ali, I guess. So are you maybe studying for a degree and having trouble with a math class? Or are you talking about like you already have a degree? Either way, the general advice is just practice, 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 unfortunately. Oh, ordinary? Okay. I guess that makes sense with I've never heard it for like an ordinary differential equation. I guess it makes sense just for that if that's a general term. Busy days usually not so busy. Then math can be done. Nice. Just before I had to click off the stream because I was going live, I saw that Zach was doing a geometry one that I feel like you probably would enjoy. There's like a weird quadrilateral thing, and looks like you could draw a couple of right triangles in there. Someone on the site would just like happen to tell me the answer. Like, it's weird to me to take the derivative with r. I guess you can. Yeah, this is it. Just you draw like a right triangle from D over to AE and then from D to A. And because, well, yeah, I don't know exactly where you go from there, but that's initially where I was going with it, at least. Extend AE until it intersects BD? Oh, extend them both, I guess? Oh! I didn't even think of that. You get a 30, 60, 90 right triangle. Huh. Okay, that's kind of neat. Shoot. I feel like there's an interpretation. Like, I definitely... If you gave me this equation in a vacuum without telling me it's the ideal gas law and like what R is, this would be no problem for me. But the whole thing with R being a physical constant, like, why are we deriving in terms of a constant or with respect to a constant? Studying for CS in Denmark, but I want to improve my math skills, especially because a lot of my colleagues has other degrees. You just came from high school, so everything seems so new. Okay. Thank you for that context, Ali. I think everyone learns in different ways, so it's hard to give general advice aside from just like practicing. The kind of resources that I normally give to people who come by and ask things are Paul's Online Notes is a favorite of mine. This website covers algebra, calculus, and differential equations, and I really like the explanations that they give. It's a very helpful tool. Like, I wouldn't call it like an entire class on its own, just like this site, but it's going to get you through your class. Like, you'll get a good grade if you like take time to like go through it and understand things. And then another thing that I like to recommend to people is if you know, studying is hard and it's pretty draining. So if you still like want to study math without having to do too much like mental effort, I guess, or you want to be able to like follow along with someone else, I'd highly recommend Black Pen Red Pen's YouTube channel. He makes usually mostly calculus, but also like pre-calc and stuff like that videos, and they're both educational and they're just like fun to watch. So those are things I like to give to people who like come by and ask a question like that. If we just look at the next section. Well, okay, R is a physical constant. The physical constant still depends on the things involved here, doesn't it? Like okay, let's look up just the ideal gas law in general. Because R isn't always the same in every situation, is it? Oh, maybe it is. Yeah, okay, so R is always the same. So, like, what the hell? What would it mean to take the partial derivative with respect to a constant? It's like doing the partial into, like, if you did, like, dp d2 or something, like, just a number. Ollie, yeah, I have a bachelor's in applied math and a minor in computer science. Like, that's such a weird question. I think I can still I'm not sure I understand context. Worked on, or I haven't studied this application of partial derivatives, I guess. Taking a partial with respect to R. Oh, Ali, I'm not a teacher. I'm more of a tutor. But yeah, if you want to teach at like a university level, that's my understanding too, that you generally need to be like a PhD student or master's or something like that. TR thing is already weird, but I'm also not sure how you describe the interpretation of the second partial anyway. That's a good point. I almost never had to do second partials in my Calc 3 class, to be honest. Because yeah, with like to classify critical points, you make a like you don't even use the second partial, right? You make a matrix out of the first partials in the determinant. Oh, okay, no, you do use the second partial for. I guess it's still concavity? Huh. Oh, it's all the second partials. It's still a little bit weird. It's not. How do you interpret a second partial? Okay. Interpretation of second partial derivative. It's like I remember like my calculus class never explained like why we just rather in this part, like is f double y, or maybe it did explain, I just forgot, because obviously I've forgotten a good bit of this, but like why is this f double x and not fxy or fyy? I assume it's maybe all the same and they just arbitrarily choose fxx. Okay, yes, and yeah, you can always switch the order of differentiation. Oh, I didn't know it was called Clairaut's theorem. Hmm. Yeah, we have a mixed partial. Huh. To R is weird to me. You may as well take a partial with respect to 2 or something. I haven't encountered a situation like that. So I am still going to say something to this person because it's been 14 hours and no one else has gotten back to him, but I can't really give him a firm answer. Is pursuing beyond candidate recommended? If so, what can I use it for? Candidate as in like candidate for PhD, Ali? Because I think different countries have slightly different terms for things, so just to make sure that we're talking about the same thing. Or you mean like graduate school, like master's or PhD, if it's worth pursuing that. Oh yeah, but what does candidate mean to you, I guess? I assume it's what it. So I'm American. I'm going to interpret that as like a doctoral or doctorate degree. So it. Pursuing beyond candidate? Okay, if you pursue beyond a bachelor's, that's how I'm interpreting your question. Or is candidate and master's the same thing? I don't know, in general, as far as I know, like going beyond a bachelor's is it's like you don't really. I mean, study 5 years in university as candidate in Denmark. Really? Huh. I guess that sounds. I guess in America it's 4 years and you get a bachelor's, so maybe that's something that's kind of similar. I mean, I don't have a PhD or a master's, But as far as I know, you only really need it if you want to get into like academia or do some like hardcore stuff, I guess. I mean, personally, I think it'd be cool to have one just like a life goal, but I don't really have a specific plan of what I would do with it or anything like that. So I think, to me, it seems something you want to do, or it seems like something you do more because you want to, rather than like something you have to do. In a lot of contexts, it's better to just get a, bachelor's or candidates, I guess, if that's what it's called, and just get actual job experience. I guess it depends on what you want to do in life. But I'm probably not the best like person to answer that question, to be honest. Inversely proportional to the square. Wait, proportional to the square of molar quantity. But it almost seems like a trick question. And this almost seems like a trick question. Okay. I never asked ChatGPT for anything. Especially not math. ChatGPT sucks for math. So y is a function of u. They give you what u is, so okay. This is the notation on this one is a little, I guess it makes sense, but it's kind of throwing me off. I kind of want to just like try working through this one and seeing what we get here. I think it'd be instructive for me to know how to do a question like this, even if someone beats me to actually answering it. I guess I'll put it there. I have a slightly different camera angle for today's stream. I'm hoping it's better. I don't know if it is, though. Let me put my mug away, though. Okay. Today I found out what you're studying. Oh, really? That's something that you choose, Petri, or what do you mean? So what are we working with? Y equals f of u. Why did I write parentheses? Y is equal to f of u. Why are you doing this to me, whiteboard? Okay. F of u plus 5x squared. Love the choice of f of u. No, but you learned the English term for it. Oh, okay, yeah. I'd love to hear it. U is x cubed minus 2x. I need to like rotate my computer so I can just like look over and not have to like step aside each time, but then my computer would be in the middle of the room like a crazy person. So du8 by dx is 14. When x equals 2. We want f prime of 4. Okay. Industrial engineering. Oh, okay, cool. Found a pretty sick SAT question, Aller. Oh, I'd love to hear it. So I'm seeing the new setup. Oh yeah, so I still need to improve it. It's a little bit better than I had it last week, but I want to get like eventually some like lighting and a better tripod, and honestly, I just want like an actual like buy a house, get a like an actual like office where I can like set it up in a corner or something. But that's obviously like, you know, a lot of money. So for now, it's gonna be janky. And actually, for a very long time, it's gonna be janky. But it's at least a step closer to how I want the stream to look. Trying to explain without showing. Oh, after I do this problem. Oh wait, actually, hold the phone. I made Zach confused. It's on a different wing of the mansion. Yes, Petri. We're about to jump in Discord with Zach. Because there's a problem that he's working on that I think I had worked on a while ago. I don't quite remember it, but I guess we have to work this out.
Hey, Don.
Hello, hello.
Okay, so we have a question for you, if you don't mind.
Yeah.
Looking at the work, apparently you were helping Beffy with a question yesterday, and we just want to clarify.
Yeah, this is a while ago, so I still need to like refresh myself on it, but I do remember this.
So the only thing I can see that just needs clarification, I would imagine is just putting a minus sign right here. I want to verify.
Oh, I need to look at your stream.
Yeah, I have it here, but I think that's what's happening.
I wouldn't put it past myself to make a mistake. I'm just trying to
No,
bring
I'm
up
not
what you
even
have.
I'm not even saying you did. Sorry. I think that's what's happening though, is that we're having if there was a minus sign right here, I'd be good to go.
Can you show where the minus sign is again? I'm able to see your stream now.
Right here. So like I have my little magnifying glass.
Okay, by that E there.
Mm-hmm. So there's 4 factors, and I would agree with all of this if we just had yeah, I think I'd agree with everything as long as there was a minus sign here.
Shoot. Where did that? Oh gosh, yeah. This was we had to use the exponential definition of things to prove an identity.
Mm-hmm. Mm-hmm. And I think that if we just put a minus sign here, we're good to go. I want to make sure you're okay with that.
It's been at least a month since I even looked at this, I think. So I probably trust you over me, like, because I'm definitely willing to like dive back into this. It's hard to me to say offhand, like, yes, that should be there, because
yeah, I think,
but I honestly,
I think that's what's happening though. It's because, yeah, I'm like 90% sure here that this is going to be a minus sign problem. That's really it. No, it's fine, Beffy. But I think that's our issue, and it would explain why. It would explain. Yeah, I think if we put the minus sign there, and then change this thing to a plus sign, we're good to go. I guess both factors exist, so we're fine. But like, if I put the minus sign here, put the plus sign here, and then put a minus sign here, we're good to go.
Okay.
Just for organization purposes, right? Because the derivative of this thing would then be this thing with a plus sign. And then this thing's derivative would be this thing with a minus sign. And then there'd be a subtraction which matches up with the chain or the quotient rule like I'd expect. See what I'm saying?
Yeah.
That's sort of what I would expect to happen.
Yeah, honestly, I would go with what you're saying on this, I think.
Okay. And I think that's what's happening. I think that's reasonable. So thank you very much, Don. I appreciate it.
Yeah, no
Thanks for
worries.
stopping by.
But, yeah, I'll see you.
Yeah, we'll see ya.
Okay. All right, that was fun. Just like a little hopping on the call with Zach to check a problem. I don't remember that problem very well, but if Zach's saying that, I'm going with him on that. And in case anyone in chat doesn't know who that was, it was oh, I'm not running StreamerBot. Oh frick! Oh my god! I need to. It should be really easy to make a StreamerBot run every time I open up my OBS. And Ali, no way the problem asked in Danish. Yes, I believe the person who asked that question is indeed Danish. 2y pi. There we go. So that's who I was just in Discord with. Okay. You know, that means Jed's first didn't get counted. Let me go into variables, persistent user globals, Jed. I'm gonna bump Jed up to 2 first now. Congratulations. First at Jed. Hey, okay, dude. I started to work out how to get a leaderboard going for those firsts, but I'm at least happy that we have that much. Okay. So I was working on the problem up there. That's right. Okay. Sorry, I'm just getting my life rearranged again. Okay. My OBS scene is good? Okay, good. So what do we... I guess we're gonna... We want to find f prime. We have a dy by dx, so let's derive each side of that, I guess. Dy by dx... Why are you wobbling again? I hate it when you wobble. 2f of u plus 5x by power rule, and then we have to do chain rule on the inside. F prime u plus 5. All right. Now, when x equals 2, what is u? 8 minus 4 is 4. Oh, that works out. Okay, good. They're not being that mean where they give us some other number and make us think even harder about transformations, I guess. I don't know if it'd be possible if you're given a different number, but... So yeah, let's take dy by dx. I don't know, I think you would usually write it as like u comma x equals 4 comma 2. That seems not unreasonable. So there's a u, so u equals 4. There's an x, which equals 2. That's not a plus, though. That's not there. So we get f prime, we get another u, which is 4. I wrote that 4 like a u, kind of funny. Plus 5, okay. So f of 4 is 9. So 9 plus 10 is 19, last I checked. F prime 4, you need to solve for. Dy by dx is 14. Okay, that's the piece that I forgot. So yeah, f prime 4 plus 5. Now this is a normal algebra problem, just isolate f prime 4 and we have our answer. Okay, that's not the worst thing in the world. Divide each side by 2 times 19, you get 7 over 19. So you cancel the 2 with the 14. F prime 4 plus 5, subtract the 5 over. 19 minus 5 equals f prime 4. I guess you, oh my, dude, what an annoying common number. What's 19 times 5? It's 195? No, it's 95. Oops. Because 5 times 20 is 100. So you subtract 5 and you get 95. Okay. So 7 minus 95 is 80. Wait, 7 minus 95. 88? $19 can't go into that because 19 goes into 95. So I say minus 88 over 19, a bit of a weird number, but there's worse numbers to get as an answer. Okay. Where was I? Here. Okay. Upper beat me to this one also. Oh, shoot. I forgot a chain rule. This piece, I forgot. So u is a function of x, so there's 3 chain rules, I guess. Or, well, basically, there's 3 different levels of derivatives. You have the power rule, you got the f of u plus 5x, and then you have the u. Okay. So upliner spot on. Oh, an hour. If there's a way to show me the problem, please let me know. If you are still here. So I guess I got a little bit distracted with all that stuff, but if not, then no worries. Oh gosh. dw dz and dz dw. Just think about the different interpretations of those. Because they're not the reciprocals. Like, they look like reciprocals, but I don't think you necessarily get the reciprocal for the answer. So they start... Was dw dz found correctly? It looks like their work... Yeah, they've only done the first part here in all this work. So you do dw dz of each side. I guess that's okay to start with. You get a product rule on this part, so they do the first part, 14z sine 8w, then 7z squared cosine 8w times 8 dw dz. Good. I agree with this left side. Is w a function of... I guess it is? This little note here is a little bit confusing. But I think I agree with this, and that note is about that part. 27z squared, w to the 4th, good. Then 36z cubed, w cubed, dw dz, good. Okay. Now you want to isolate dw dz. So you're gonna have to subtract over this cosine term and factor it out, or bring over the other term. Just checking if there's an algebra error, but it all looks good. Then you divide each side by that thing. I think I agree with their work here. So it's a little bit weird with like a... Boy. An implicit function. And actually, I think dzdw might actually just be the reciprocal of this. Because you're gonna do basically the same... Yeah, it actually will be the reciprocal, because you're gonna get these same, like, derivative results. It'll just be, like, instead of dw dz here, you'll have dz dw over here, and same over here. So you just end up, I guess, basically flipping it. I wonder if Wolfram will know how to do this. Be interested to verify it with that. I guess by like this. Sine 8w. Nine z cubed w to the fourth. 9z cubed w to the fourth. Can't really, I hope those are all inside the differential. Oh, it differentiated both sides, but it didn't. Yeah. Oh, this might be it. Wait. Oh, the z's canceled. Well, only one z cancels. So you have the sine only ever has a z to the 1. Okay, so they didn't make a mistake here. That's z to the 1. So this z can go away, but all the others just get z to get their power reduced by 1. So they actually did make a mistake here. Is that really z cubed? Z cubed comes from there. I guess so. Why does Wolfram Alpha not get a z cubed, though? Really? I guess there's a, Did they make another mistake with the z's? Should that z squared be z squared? D by dz, 2z. I'm wondering if Wolfram Alpha is interpreting the problem wrong, or if, so I don't see the mistake in this person's work, to be honest. But it still doesn't, even if you fix that bad cancellation over here, you still don't get something that matches Wolfram. Which is a little confusing. Yeah, I don't see this person having done anything else wrong, so I'm just gonna say it's a mistake on the last step. You can only cancel one power of z because it's minus 14z sine 8w on top, not z squared. I don't see an error or anything else though. Yeah, I don't know if Wolfram was right or wrong here, so I'm just kind of going with my gut. Calculus with analytic geometry? That sounds scary, but it might... This just looks like a normal limit problem. Assuming they haven't gotten into the stuff that I don't know yet. I think that person gave a good response though, so let's move on. Oh God, it's so long. This looks like an interest problem. It is an interest problem. I use the first solution method rather than solve a problem when I initially countered it. They're trying to wrap their head around the second solution. Let's see if we can figure it out. Take a 3-year loan for $10,000. The interest rate is 6% compounded annually. At the end of each year, I make a payment right when the annual interest is added to the amount that I owe? Like after? Why would you do that? Why don't you pay it just the day before? What? Okay, I guess that's what you do. You just like spending more money than you have to. Okay. So I guess I would think to do it in this splitting it up by each year thing as well, since you only have 3 years, so you don't have to worry that much about like some kind of general formula. Just do it step by step. Draw by memory a Mobius strip, Anders. Okay. I like it. Trying to remember what it's gonna look like. So I think they're normally drawn in like a figure 8, and there's like a rotation somewhere in that figure 8. Or is it just a loop? And there's a... No, I think it's just a loop. And there's a flip inside that loop, right? I guess we'll see. Okay. The Mobius strip may be up there. Oh God, that's gonna be so hard to draw. Just start with something and we'll like modify it, I guess. So just start with making one loop. And then I believe... Oh God, it's not very symmetric. Like it has to like cross over itself, doesn't it? Well, then how do we get it back? Wait, is this even possible to draw? I guess, do I make it cross over again? I don't know if that's a Mobius strip though. Should it only cross over once? Like, I don't think that's right. Oh, I think they need to connect these lines. Oops. Like that, and that's a Mobius strip. Right? Okay, so I'll go check chat now. But you said by memory, so I guess that's how I remember a Mobius strip. Am I allowed to Google it now? You're not okay with that? Let's see. Oh, should there be two folds? No? Right, kind of... Yeah, I don't know. That's the best that I got for you. Wikipedia seems like the simplest. The half twist. Wait, I mean, I feel like I kind of... Well, I guess the lines do cross over. Well, that's a perspective thing, though, isn't it? I guess that's also a perspective thing. All right, I guess I would have made them cross over twice. I had it right the first time. I'm still taking those points, though. Can you check the... Or you can check the one-sided property. Oh, for what I drew? I mean, I don't know what I drew, though. I guess you'd have to see if your drawing is correct. I have a hard time even visualizing it. Oh, I was gonna show my browser when I was looking at the Mobius strip. But I was saying like, oh, there, crosses over here, but I also noticed it crosses over there. So I guess I should have made them cross over twice to do what I was thinking. One crosses. Oh, okay. So I was right. I was wondering, like, I guess I don't know. Yeah. Yeah. Okay. I guess you're right. I am right with only the one crossing. I didn't draw it right, but maybe I did have it right then. Kind of. Well, at least you want to try again after seeing the correct image. Uh, okay. I'll try to draw this shirt because I feel like I did kind of scam you a bit with taking those points. I'll even do it in green. Uh, okay, so we'll start with the left part. Okay, and then we have. I guess we'll still draw the second crossing from the like perspective, I guess. That's going a little too far down, isn't it? Oh, actually, no, that's okay. And it needs to curve back around on itself. I mean, I guess I should actually draw like this so it only crosses over the ones. I feel like I just drew the same exact thing twice. Now we should do the perspective. Well, should we? It's no, okay, so if we're gonna do the perspective, this bottom line should disappear at some point. Around there. And then this one becomes the bottom line. And this one just pops out of there. That looks so bad. Like, am I supposed to do it like that? I don't know. If you zoom in on the cross section, there's like 3 lines. Yeah, I don't know. This it hurts my brain. I don't know what else to like do. Seems good. All right. Thank you for letting me off easy, I guess. Five out of 10? You don't even need to cap with that because I would completely agree. AMD over on YouTube. Yeah, sure. Please do. Actually, 5 out of 10 might even be generous. Okay, I was about to say, like, if you pay it off right after you compound it, isn't this just like simple interest? Oh. Okay, so I think I understand what's happening with this second solution. Let's make sure no one else has beat me to answering it. Nope. And yeah, MD, as soon as I or as you complete your thought, I'll switch over to looking at your question. making payments, the interest gets added, which turns it into something more similar to simple interest. You're still taking it year by year, like in the first solution. Actually, it's not necessarily just year by year, because from the way they're saying it, it's a 2-year loan that's still compounding annually. We're given all the payments are the same? All payments being equal and completely paying off the loan. You're still sort of taking it year by year like in the first solution. Okay, but instead, it's sort of, or instead of the year by year approach, it's almost more like, or it's like, it's taking it payment by payment. No, Andy, I'm just working on this in the meantime. Just type your question in chat and I'll switch over to what you're asking. I'm just working on this in the meantime because I don't want to just like be idle. Just please go ahead and ask though. Your first payment only gets hit with the 6% interest. Oh my god, instead, interest once. So you just multiply by 1.06. The second payment gets hit with the interest twice. So you have to do 1.06 squared, and similar with the third payment. They said think of all the math, so I'm not emphasizing that part. They're asking why you're able to divide up the loan in that way, and I hope this addresses their question. I'm wondering if I need to add in something more though. to do it this way because each of the payments are the same. So you can look at what happens to each third of the payment, basically. I shouldn't say basically. Just say period. I think that's what I think I'm gonna leave it at that. But yeah, AMD, please just type your question at any time. The solution for the following quadratic inequality. They want this parabola is greater than 0. Really? Oh, okay. They do get, okay, I was wondering if they give you the same parabola there and there, and they do, which would be annoying if they didn't. So they want when this parabola is greater than 0 or equal to 0. I'll just type back to AMD in case you have me on mute or something. But no, even if I'm doing something, just ask, because I'd rather help out people from chat than work on random questions on the internet. Oh yeah, and my music paused. Let me fix that. Hey SPQ. The main wish is to invest 10K in stonks and receive a return of 100% within 3 months. Formulate the portfolio given the constraints. Put it all in Bitcoin. It's the best stonk. A practical one. No, if I knew the answer to that, I wouldn't be telling anyone. So I assume you have to shade the graph, like... You can just put it in Desmos too. Or you have to factor it and think about it a little bit differently. To be honest, I've done this for a quadratic, which I feel like we just did at some point in real analysis. Whoa, brother. Why are you so weird? Where's the parabola? Wait, is it really just everything outside of -1 and 3? That's so weird. How like the parabola just goes away. So the parabola is positive? I guess so. Yeah, that's probably a better way of thinking about it. It makes me uncomfortable that you just ignore the parabola entirely, but I guess it makes sense. Yeah. So I know it has to do with the zeros a bit. It's weird. Oops. It's weird to me that you go above the parabola, I guess. But there's no reason why you don't. Huh. All right, fair enough. All right, so you shade the region of the graph where the inequality is true. Y of x is parallel above the x-axis. Yeah. Oh wait, I suppose they had that little. That's for number 6. Do they want an actual? Wait, 7? Is there a typo? Or I guess 5 is on the last page before this? That's so weird. Why would you do it like that? Okay. So I don't think you shade the graph. I think you just use it. Ah, okay. That makes more sense. They don't want you to shade it. I was like, this is so weird if you have to shade it though. Of x is so for 5, what values of x make x squared minus 2x was 0 true? It's helpful here to both sides of each 0. There will be 2 inequalities. Seeing 100% API isn't obscenely difficult. Yeah, you'd have to like short and get insanely lucky or something, and be a lot of risk. Oh, what's happening here? So you have to find a quadratic that fits these constraints. They give you f prime of 2 and f prime of 0. Why do you need to use the limit definition of a derivative? Why can't you just... What? You can just make a system of equations, can't you? Why is the limit definition of a derivative helpful? Oh, because you have to... Oh, no. You can't just do this the easy way with the power rule. They need you to actually... Do you have to do it twice, dude? Because I think how you solve this problem eventually is you plug in 2 for x into your original quadratic, set it equal to 3, then you derive this, plug in 0 and 2, because that's what you're given values for, and then you have 3 equations and 3 unknowns. But I think you have to get f prime using the limit definition of a derivative. And I guess you have to do it twice, because you have to do it at a specific point. This is... Well, wait, if you're plugging in numbers, though, isn't this... Well... I can see that they're making you do the limit definition twice. This is... What an annoying problem. I still want to solve it. Where am I going to put this thing? Squeeze it up there. Hopefully it's not too hard to read. All right. So we know that f of x is ax squared plus bx plus c. We know f of 2 is 3. F prime 2 is 7, I want to say. Yep. And f prime 0 is 1. And for some reason, they shoehorn in the limit definition of a derivative because they just hate you, I guess. Okay, so I guess that they probably want you to prove it for f prime 2 even though they gave it to you. Like, I don't know, man. So f of 2 plus h is a, no more x's. Wait, no it's not. Yeah, yes it is. A 2 plus h squared plus b 2 plus h plus c, and then f of 2 is 4a parentheses 2b plus c. And you have to do this all over again with 0, I guess. I don't know what else they expect from you. Hey, Dr. Gold. Yeah, exactly. This problem, they're just making you do work for no reason. Wait, 2 non-parallel planes intersecting in a line, Anders? Oh, wait. Oh, no. Okay. I thought you were asking me an impossible question. But that happens all the time, right? Non-parallel planes intersecting in a line. What color do I want to do it in? I'll do it in black. Put it over by your Mobius strip. I guess my Mobius strip. You probably don't want ownership of that. So we'll draw one plane like that. And then we'll draw another plane. Oh God, what is that? Who drew that? And they're intersecting. I'm trying to make it so it's in like, dude, the perspective is horrible. Like, I'm trying to make it so they're like mostly like perpendicular, I guess. I don't know how to draw that though. Hey, Yeri. Got no interesting, but just common problems. X less than A or Y less than A? Do you need help with that, Yeri, or just like set up for a fun problem? Sounds acceptable? All right. At least I didn't draw like... I said drew something that was true. Just a common problem? Oh, okay. All right, so now, because this person's teacher hates them, we have to evaluate that limit. Oh, wait. Actually, I'm going to switch to red because this problem makes me angry. All right, so... we have the limit as h goes to 0. We have to multiply that out, which is going to be 4a plus 4ah plus ah squared. That's going to be 2b plus bh, aka butthole, plus c minus 4a minus 2b minus c, all over h. Now we group the h terms, get a cancellation. Well, wait, do we do that? What do you do with the constant terms? Am I dumb? I did this before, like last week, and I just forgot. Erase the part of the plane that is hidden behind the other, and that will be perfect. Oh yeah, you're probably right. Okay, erase the part of the plane that is behind the other plane. Just like there. Oh wait, so wait. This is why I can't do art. I think that's right. What happens to the constant terms here? Because you can definitely factor out an h from those three terms, but you get like infinity with all the constants over h, don't you? So I'm getting confused here. I might honestly need to look back at how I did this in the real analysis class, because with A, B's, and C's, it just looks so much harder. Oh wait, 4a and 4a cancels, 2b and 2... Oh, that's it, duh! All the constants cancel, there we go. Over h, that makes it so much simpler. H goes to 0. I need an ultra red, because it's probably just going to be angry all over again. H plus b, which is just 4a plus b. And wouldn't you know it, 2ax, plug in 2, that's 4a. You just get b. You get 4a plus b. But you have to do it the long and hard way, for the sake of this problem. Don't ask me why. Okay. And they do give you it's equal to 7. All right, so now you get to do it all over again, but with f prime to 0. As far as I'm interpreting this problem. At least 0 is a little bit easier. It is 0, right? Okay, yeah. All right. This is definitely helping me learn the limit definition of a derivative. This definitely isn't a pointless waste of time. Get another butthole. At least that makes me laugh. F of 0 is just C. H. That's AH, that goes to 0, so you just get B? That doesn't make sense. You should just get C, right? No, you should just get B. No, you should get 2AX. Am I doing too much in my head? Get A times H, and H goes to 0. Wait. What? Oh yeah, it's just B, it's just B, it's just B, it's just B. Because you derive it, so the x there goes away, but you still plug in 0 into the A, so you just get B. And we said that's equal to 1. All right, and now the problem answers itself. Well, it doesn't, but you plug in B up there. Get 4a plus 1 is 7. You get a equals, that's 6, man. They don't even give you clean numbers. 3 over 2. And then you come back up here, plug in 2. Which is 4a plus 2b plus c. Plug in a, you get 6. plus 3 plus c equals 3. C equals -6. All right. Stupid problem. There's one more line? Oh, you're right, there is this line. All right. I think that's right. Hey, welcome back, Hoo-Hoo. Okay. What is the question? The question is what they posted. I'm a little confused by that. All right. So there were like calculators saying the way that makes sense to do, but I don't think the teacher asking you to do it the way that makes sense. So I'm prime of 2 using the limit definition, then f prime of 0 using the limit definition. It's a bit tedious, but you must use the limit definition and provide that filled in version for f prime 2. So that seems to be what they want. As an example for f prime 2, working from what was given, you do limit as h approaches 0 of a2 plus h squared plus b2 plus h plus c minus ah squared plus bh plus c over h. You'll find that the terms without h will cancel and end up with 4a plus b, which you can set equal to 7 from the given information. You then need to follow a similar procedure with a 0 instead of 2, and you'll find an answer, and you'll find what b is. Use that value of b to find a from f prime 2. Then find c using f of 2. All right, that's my answer. Draw a line that intersects perpendicularly to a biplane? Is a biplane like the thing that I just drew? Well, Oh, it's also that. Wait, that kind of biplane? The airplane? We have quite a few different surfaces that you can intersect perpendicularly with. Okay. All right. We can do that. Uh, I mean, I'll put my reference image on stream here, even though I'll be able to see it as I'm drawing. Okay. It seems like there's a thing in math called the biplane, though, which is interesting. I don't know what it is, but... Okay, so... I guess let's start with the wings. Seems like a natural place to start. Now, does this lower wing... Okay, yeah, it goes, like, underneath it. This is looking a little like a dick, I'm gonna be honest. Just get a fin on it, and it'll be all good. Yeah, that really helped it not look like a dick. Okay. See, so let's get some wheels on them. Where's the wheels? Uh... Oh my god. Okay. It's waving? Yeah, it sure is. Get a little windscreen in there. We have how many? I guess it's two. I guess it's okay. It's a biplane. There's only two propellers, right? That's what the bi and biplane is. We'll get some little action lines. I guess we need some those like support beams, right? All right. We should get a little design on it, right? You know, this will be a DDM plane. Put some red flames on it so it goes faster. Wow. All right. And then I don't know. It's like some stripes or something, like this little bumblebee. I don't know. Okay. And then we need to make a line that intersects that biplane perpendicularly. And so I really want to intersect those two wings, right? You know, it seems like the natural place to be perpendicular with. Like that. How's that, Anders? Yeah, it's a drawing routine that Anders did. Seems good? All right. The challenge was draw a line that intersects perpendicularly to a biplane. And I thought a biplane was an actual like math term, which I guess it is, but I wasn't familiar with it. But Anders meant an actual like plane biplane. Get rid of that. What's my DM? For the first one then, is the answer -1 is less than or equal to x, and x is greater than or equal to 3. -1 is less than. Gotta think using my brain. That factors to x minus 3 times x plus 1. And yeah, they do just give you the zeros are -1 and 3. So yeah, we do want less than negative x. X is less than -1, but -1 is less than x is the flipped. So they need to flip that inequality. Right, yeah. And then x greater than or equal to 3. Yeah. Zach! Thank you very much for the raid. Welcome in, everyone. Hendra K. So I think, Zach, you'll in particular enjoy what Andrews has had me do. So on the left side of the screen there on the whiteboard, that green thing is supposed to be a Mobius strip. Actually, I'll even come over and, you know, present my artworks. So Anders had me draw this Mobius strip, which of course is flawless. And then I had to draw two planes intersecting in a line. And then I had to draw a line intersecting a biplane perpendicularly. And of course, a biplane is an actual plane. Apparently, there's something in math also called a biplane, but yeah. Before we get draw a cat ninja. Oh gosh! All right, a cat ninja. That is fitting with what happened in real analysis. I have some room right there. Cat ninja. How should we do that? So you're drawing, not mine. Yeah, no, I I know. I'm just buying some time as I erase this because I want to do a good job with this ninja cat. Okay, so I'm thinking like ninjas are normally in that like, you know, black like costume thing. So we should have a black cat because they're naturally ninjas already. Okay, I guess we'll do. Oh, well, I'm trying to figure out the pose. Okay, so let's do. Okay, this is this is gonna be bad. We're gonna want a cat that's like kind of standing up. Uh. Okay, it's not a terrible start, right? Gotta get that tail for counterbalance. I don't know why its tail is like more inflated on one end, but you know, it's not my problem. All right, so we'll have Oh my god, no, okay, that... And I think my ninja cat is, like, it's gotta have nunchucks, right? Like, nunchucks are like the coolest thing that a ninja has. And then, where should we, I guess the other paw can go down there. Let's get that perspective right, you know? Kinda right. Then you know, our niche cat has to be very serious. Well, wait, wrong? You said 20 streaming 25 days out of 30? That's weird. Is that a cat or a squirrel? It's a cat, all right? A katana? No, I mean, okay, I'll have a katana on its back. I do like that idea, but like you gotta have nunchucks too. I guess the cat will be looking right at you. Oh God. That eye is a little bit. Oh God. I kind of saved that nose a little bit. Oh my God, it looks like it has a hunchback, dude. That's what the cat's like. Okay. We'll do frick. Okay, what is a katana? How would it look when it's across the cat's back? I guess like that. And then we should get a little like red eye band, like the little emoji had during real analysis. You know, that's not the worst thing that I've drawn. You know? Katana's for a samurai cat? Oh, you're right. So, Ninja Cat, not Ninja Turtle, yeah. So, you know, I think I could have done worse there. Raphael. That's a little. I'm trying to think. Donatello, Raphael. Oh my God, why can't I? Michelangelo, Meowchelangelo, Leonardo, Meownardo. That's like the closest sound to like. I mean, Leo's King of the Cats. Oh yeah, yeah, that's clever. You're good, Frederick. I want to get the actual symbol for this person. Change the clear mask to match. Oh, that's true. The katana? Katana? Oh gosh. X less than or equal to 1. X. I did not pick that up the first time around. You gotta really spell it out for me, I guess. Yeah. All right. I'll put the webcam back down so you have to look at my abomination of a cat. Cat is a category of small categories? Frederick, yeah. I went to university in Hawaii, but most of my life has been in California. Draw cat given the updated definition? Wait, you didn't even actually redeem it. You just put the text. I don't know how you, like, a category is an idea. I don't know how you draw that anyway. Go to learn math. In Nepal, there used to be a cat that looked like a man. Eric kept asking him, what did the cat man do? Oh, Catmandu. That took me a minute. Yeah. I don't remember what that was in relation to Nepal, but I remember it has something to do with that. Nope. To that first one. Ooh, what's that about? Hmm. That's kind of fun. I think you tried different values of the parameters, and you would say that a higher parameter correlates with like a lack of communication, or like whatever. Depends on how the parameter behaved, I guess. But hmm. Do Donna and a cat have in common? They both have excellent whiskers because cats have whiskers. Oh god damn it! Is this gonna be a joke explaining like thing now? And Frederick, I went to Hawaii Pacific University. The number of letters in the first name of the composer of the musical Cats times the number lies at. Oh my god, I don't know the first name of the composer of the musical Cats. I'm gonna have to look that up. Composer of Cats musical. Oh, is it gonna be 9? Andrew Lloyd Webber. Oh, okay, so that's 6. 6 times 9 is I'm gonna get this wrong. No, it's 54. Does Wolfram Alpha know how to do that? I really hope Wolfram Alpha knows how to do this. Come on. You can do some weird things with Wolfram. Oh, letters first? Okay. Oh well. I was just curious. You do like, Age of Chris Pine times like something, but I think this is like maybe too many. Too many words. Yeah, 54, Jed. ChatGPT probably could, but I'm not going on ChatGPT. Okay, you still aren't putting the letters first, Wolfram? Okay, you know what, Wolfram? I give up on you. uh... So I worked on, or I worked with, not on, but I worked with the SAR model as an undergrad research assistant for my professor. The thing is, she didn't really explain to me what the actual parameters of the model meant. And I'm trying to see if I can find that out quickly. Yeah, I think it's super cool. Okay, so like gamma is the recovery rate. I would think that it's like rate of social contact and rate of transmission upon contact. So like beta might be something that you could vary where if the government communication is saying to reduce your rate of social contact, that'd be like you just that'd be like reducing your beta, I guess, or reducing chi, which reduces beta. I thought there were 4 parameters though. I guess that's all I remember. Maybe. Oh, okay. What are the actual, like, what does the solution even look like, though? I forget. Or does it depend on the situation? Voss slalom? I'm... Oh, it's skiing? Oh, I guess slalom. It almost looks, it looks more like a desert because of the filter on that picture. Okay, now that little one down there looks cool though. Okay, so figuring math at a high school level. This is a little bit beyond high school. Well, I guess they're in Denmark, and people in Denmark are probably smarter, or they probably go farther sooner. Do you know that in French the word ChatGPT sounds like chat jappe? Kitty, I have farted? Really? We're going to Google Translate. All right. That's kind of hilarious. I haven't pronounced the left side. Oh. It's not going to show up on stream, though. Sha jepete. Okay. Cat, I farted. Yeah, it does sound just like chat GPT. Do 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 do. Do 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 do. Is to look at the value of chi. Oh, yeah, that's a real good chi right there. There you go. Calculation, doing a simple calculation of it with a given value, then do another Then interaction. Then propose that government communication to shelter in place reduces rate of social interaction by, say, I don't know, what's a good percent? 60%? The number is arbitrary. Actual number. And then do another calculation with 60% of that value, keeping everything else the same. You'd hopefully see fewer infections in the end results. All right, so I hope this is kind of what the person was asking. I'm going to post that. See what our DM is. He said thanks. All right, awesome. Here's one without any comments. Let's see. Oh, is this work? Please don't tell me it's work. If it's related rates, I'm all here for. Oh, it looks like work. Oh no. Okay, a water tank shown below is shaped like an inverted cone with height 8 meters and base radius 1 meter. If the tank is full, how much work is required to pump the water to the level of the top of the tank and out of the tank? Oh no. Wait, is 2 related? Oh no, 2 is a different problem. Wait, are they asking? Oh wait, they're asking about both of them. Find all numbers of b such that the average value of f of x. Oh, that's a much simpler problem. So the cross-section of your cone here is going to be a circle. I assume our integral is going to go from 0 to 8. But if it goes from 0 to 8, we need to relate the radius of the circle to the height at a given point. So, I mean, I can just look at their work and see what they did and see if it makes sense to me, I guess. X over y equals 1 over 8. They're just making the line that represents like the side of the cone. That's reasonable. I see. This is okay. It's not the way that I was like imagining, but this is they're figuring the area of the circle in terms of the height of the cone, which is good. I like that. See, our integral is going from 0 to 8 of the weight, or okay, the force due to gravity on the water, and then you have the density times the volume, which gives you the weight, or the mass, and the mass times the force gives you what do you want? Well, I also throw it at the end there, but I'm pretty sure this is what we want. So you need the volume. We have the area of the circle there. So that 8 minus y and dy? Do you need the 8 minus y? Because I thought dy would account for your thickness. Does Paul have a thing on this? I bet Paul does. Okay, this is basically the exact same type of problem. Except that it's already filled with some water. I'm interested, I guess, in the 15 minus... Oh, yeah, because you have to track that same section of water as it moves up the cone, I guess. That's what this is doing. I guess I can buy this. I'm not quite sure why it's approximate, but I don't think that distinction is too important for the sake of the person doing this problem. This is the mass. Why is it x sub I squared? Oh, because of the area of the circle. I think this person set it up right. We can go and check their algebra and their calculus here. 9800 to zoom in here. Is that supposed to be pi? I guess it is. Yeah, so 9800 pi over 64. Yeah, because they already dealt with the squared before. Y squared 8 minus y. They simplify that fraction. Multiply the y squared in. Why is that? Oh, they were. So yeah, please do. 8 over 3 y cubed minus y to the 4th over 4. Okay, from 0 to 8. Yeah, I think I don't see a flaw in their work problem, I guess. I'm not the strongest on work problems, but that seems okay. We can put their initial thing into Wolfram and make sure that the final answer matches too, I guess. Pi. No, Wolfram, I know what I'm doing with this. Stop putting parentheses. Oh my, no, stop, Wolfram. You were the worst. Oh my god. Thank you. Should not be that hard. 64. 8 minus y, x. Wolfram alpha gets... Why is there no pi? That... What? How does the pi go away? They multiply it in, and they somehow... Oh, they oh, that's... I hate that. I hate that. Let's look at Buzza's problem. That's more important to me. Oh. What is happening here? Each limit below represents f prime a for some function f of x at some x value a. For each limit, identify the function in the x value. You do not need to evaluate the limits. You may be able to answer this question without showing any work, but you can sometimes show work if you find it helpful. Oh, okay, this looked much harder to me at first because the signs here are a little bit hard to read, whether it's like plus or minus. It's I guess the horizontal lines, but okay. So that's a minus sign there, and that's a plus there, and that's a -2 there. It's a little bit weird that it was showing up like that. Okay, so this isn't as bad as I thought it'd be. Interesting. Okay, so I have to make sure that I have this right in my head. I think I know how to do this, though. I think it's really just knowing how to work with our definition of a derivative here. So let's spell this out. So the definition of a derivative that seems like you're working with, which is completely fine, is the limit as x approaches a of f of x minus f of a over x minus a. That's like the general formula there. In the situation that you have in the first one, you have the limit as x goes to -2 of sine pi x, oh yeah, minus 0 over x plus 2. Okay, yeah, that seems to match. So they want you to name the original f of x, not f prime x. Interesting. So for this first one, I would look back at our formula up here and kind of match things up. So f of x is just the original function they're asking for, it seems, and we have a sine of pi x right there. So here I would say that our f of x is sine of pi x. And for the same reason here, like, it's better if you even look at the denominator. You have x minus a here, and you have x plus 2 there. So note that there's a sign flip. But you have a 2, and the way you get a plus 2 there is if it's a negative 2. And also, you can also just look at the limit as well, which goes to negative 2. So I would say this is the limit definition of a derivative if your original function is sine of pi x and your a is negative 2. And it checks out with a 0 there because if you plug a negative 2 into here, your f of a, f of negative 2 is sine of pi times the negative 2, which is the same thing. If you can, sine is odd, so you can bring the minus sign out front if it helps you. Negative sine of 2 pi, sine of 2 pi is just 0, and negative 0 is just 0. So you set it with a 0 there, and that matches there. So that's another little like check that you can do if you're not sure if you're right. I hope that makes sense for the first one. Oh, then they use the other definition here. I see how they're like quizzing you. So that's for the first one. So I'll work on the second one now, unless you have a question on the first one. So the second one uses the other definition of derivative, which is the exact same thing, it just looks different, which is the limit as h goes to 0, f of x plus h minus f of x over h. And what do they actually have when you plug things in? For f of x, you would just state it to be sine of pi x. Yes, but I'd say that this is your answer right here. Because f of x is just included in the formula here. So you can just take that at face value for your f of x, basically. Yeah, that's how I'm interpreting it. They just want to make sure that you know what each piece of this formula means, is how I'm interpreting this question. Do you want me to work through the part 2, or do you feel confident with it, or I'm happy to do whatever you want there? Or I guess part B? Yeah, sure. So 2 to the 3 plus h, interesting. Okay, so this is the other limit definition of a derivative. This one and this one, they mean the exact same thing, but they look different. They're both completely valid. Sometimes one is easier to work with than the other, but they accomplish the same thing. And so here it's the same exact idea. I see an f of x right there in the formula, so let's just look down here for where our f of x is. Well, it's evaluated at a point, so we actually have a 3 there. Wait. Oh, yeah. I was getting tripped up. That's right, because for this one, okay, that is kind of a neat thing that this question is pointing out. Because this one you have an x, but in this one you don't have any x's at all. You just have the h's to deal with. But how here so the thing that I guess the thing that can be hard to interpret is, do you have 2 to the x or x to the 3? And how we figure out that is the 3 plus h. It has to be something where you do the x plus h, you get the plus h in the exponent, and that's how we can know that the original function must have been f of x equals 2 to the x. And it's going to be evaluated at a equals 3. And if we were to go backwards and plug things in, we'd say, starting from this, f prime of 3 is the limit as h goes to 0. Because when you, like in this definition up here, you only plug in the value that you're evaluating at into the a's, so you still have the x's in there, and it's a little bit more direct to see what your f of x is. But here you do have to do a little bit more thinking. So, because you actually have to plug in your 3 here into these x's. So working from this, 2 to the x, if we want f of x plus h, it's going to be 2 to the 3 plus h. And I should say maybe like it'll be a bit more clear if I say f of x plus h is equal to 2 to the x plus h. And then in here, we're taking x to be 3. So that's why this x plus h turns into 3 plus h. And then minus just f of x is 2 to the 3, because we're taking x to be 3 again. Then over h. So I probably could have explained that a bit better, but I hope that kind of makes sense. This formula is a little bit less clear for what's happening. I guess you have to look at where the plus h is, and that's where your x goes, is kind of the most important message here. Yeah, I guess let me check again and see if you said anything. So yeah, let me know if that at least helped explain it. Wow, thank you, Marker, for following on me. But I definitely say that kind of like tripped me up too, so I wouldn't blame you for feeling iffy with it. Yeah, exactly. So you have to do a little bit of thinking about where that h is and what the function must be given the h is where it is, I guess. But thank you for the question. Glad I was able to help. Okay, so all right, we're gonna do this work problem. You want to see another example of something like the thing you just posted? Let me think of one. All right. So since this was a trickier one, I'll do a limit doing this like trickier one. So it sounds like you're pretty comfortable with the first one. Okay. So I'll rewrite the definition that I'm gonna ask you to use. X over H. And so now the problem I'll give to you is, I mean, I'm happy to like help you like work through it too, but I definitely want to hear from you about what you think of it. Let's do ln of I guess 3 plus h minus ln of 3 over h. How about that? So what would you think is our f of x? What do you think is our a here? Filming the whiteboard on the wall, but you erase like a little girl? It's because I have the whiteboard on hooks and like that are just like stuck to the wall, and so I don't want to erase like that hard. So I have to go to like the little girl erases, I guess. That's my excuse. Anyway. Is it 3? F of x is never want to rub too hard? Sure don't. Yes, but I'd absolutely agree with you. Because like f of x is ln x and a is 3. Because the plus h is on the inside of the ln here, so this must have been our x plus h. And then 3 is kind of the thing that's consistent between those two, so I'd say we're evaluating it at 3. There is a trickier thing that I might be able to give you. I don't know if your teacher would be mean enough to put a problem like it on here, but if you want, I can give you a bit of a trickier one. I would just need to set it up in a place where you can't see the original thing. So I have to figure out how it looks. Just leading to the first. Okay, so I mean, let me actually I need to keep that. Let me just think of how I would make this problem. We have it sure is, Zach. Shout out to the real analysis class, because that did help me out a lot with that problem right there. So what I'm gonna have you do, oh God, I can make it really hard, or not like really hard, but I can make it kind of mean. I'm not gonna make it that mean though. Let's do, that's what she said. Would that work? Let's see what that comes out to be. There was no. I'm overhyping. I'm just thinking there is like kind of a. It is possible. Oh God, no. That I mean that one. I mean, we could make it that. Okay. Almost done. So I'm around to do a certain thing for me, so I don't have to do it. Okay. All right. Let's make sure that I know how to do my own problem here. So if your teacher is feeling tricky, They could give you something where it's not immediately obvious. Or like, I don't want to say immediately obvious, but it could not be much less obvious what your original function is. So I'm going to say you have h squared plus 2hx minus 3h plus x squared. And I'm going to just like show you the answer on this one, because I don't know if you'd even would realistically get this on a test. So I don't want to like actually there'll be a little trick that we can do here. Oh shoot. I'm doing this wrong. You know what, I'll even, oh god, you can make it way meaner. I'm gonna be nice though. We don't want x's in this. These are ones. It's 3 times 1 minus 4 over h. I think I set this up right for you. So synthetic division? No, so yeah, it doesn't look quite the way that I was thinking in my head, so it might be a little bit like too mean, but the thing I was thinking would be like absolutely evil is if you actually like combined all of these numbers and like you didn't have the ones there or something. That would make it super hard to decipher what's going on here. But the thing that's kind of, if you were given something that's like that, I would look at this part, because that's your minus f of x. I did make sure to write it so that's at least there's a little bit of a hint there where you have the minus sign in the parentheses here. So you, I mean, it doesn't have to be, but this is your f of x here. So I don't know, this probably might not have been the best idea to like give you, but I'm trying to make a point that it could be you have to think outside the box sometimes to figure out what your original function is. Depending on like how mean your teacher or professor is, I guess, but synthetic division. No, you don't have to do synthetic division here. You don't need synthetic division to do the limit or to figure out what f of x is. At least for the purpose of figuring out what f of x is, you basically have to notice this is like a quadratic because you have a 1 squared and a 1 and then just a constant term. So I'm going to say that these ones are like x's. So you'd say x squared minus 3x minus 4. And you plugged 1 into that. And so you could also draw the conclusion from this area over here with the h's, but it obviously looks like a huge mess. And it is a huge mess. But it's a bit simpler if you key on the area that correlates with just the f of x, and you look at the numbers that is consistent there. So again, that might not be the best example to have like shown you, but that is like something that's a little bit harder, that it's possible there's something like that. You see? Okay. How you do the first part? Oh, if you were to want to do that limit? Oh yeah, I can certainly show that. So yeah, if you want to follow this limit all the way through, well, you notice we have +1 minus +1, -3 minus -3, -4 minus -4. All of the terms, from here on add up to 0. So you just end up with these things on the left here that have the h's. Over h. And now all these things have an h, so let's cancel them. H squared becomes h. +2 minus 3. So that h becomes 0, the 2 and the 3 are constants, so you get 2 minus 3 is -1. And doing calculus, doing like the power rule, 2x minus 3, plug in a equals 1, yeah, you do get -1. Okay, so I just like manually verified it in my head if you took the derivative of that the normal way without using limits, and it matches. Okay, and you could also have combined the 2h and the 3h earlier on too. I don't know why I kept them separate, but I hope that makes sense. Chapter needing to the d by dx of trigs now. Oh, okay. Good luck. Well, let me know if you run into anything else. Okay, so this person got 19,600 over 3 pi. Yeah, you too, Budza. Tron 205. Oh, so they did make a mistake here, I guess. Everyone gets 164. Or made an entry error, that's always possible too. Or 1225 over 8. They did that simplification, right? Eight to the 4. Over 8 times 12. Oh, wait. Okay, so that's the 8 from that fraction. Wait. Didn't they forget? Where's the 8 cubed? Oh, wait. 8 to the 4 over 3 minus 8 to the 4 over 4. Oh. They didn't do that fraction math right. Because that's 4 times 8 to the 4th minus 3 times 8 to the 4th. It feels like there's a trick there. Three. Oh, you would factor out the 8 to the 4th, and it's just 8 to the 4th? 4096? Put that in parentheses. Actually, 8 to the 4. That should be 496 as well, right? Okay, yeah. So let's do 1225 times 8 to the 4th times pi over 12 times, yeah, if we do 8. 164,000? Is that? Yeah, 201. Okay, good. Okay. So we did find an error at the very end of their work integral here. The way it set it up seems okay to me, though. Find all numbers of b such that the average value of f of x is equal to minus 9x squared plus 10x plus 4, and the interval 0b is equal to 5. Interesting. What is the... I don't remember the average value of... Oh, yeah, it's 1 over b minus a times the interval from a to b. And they're going to set it equal to 5 at the end. Okay. So you get minus 9 over 3x cubed plus 10 over 2x squared plus 4x. Over b minus 3b cubed plus 5b squared plus 4b, right? Multiply the b in, you get minus 3b squared plus 5b plus 4, good. Set equal to 5. Subtract the 5 over, it should be minus 1. Oh, but they multiply through by negative 1. All right, that works. You get an annoying quadratic. I wonder if Wolfram Alpha knows how to do this. It's gonna be a little Wolfram Alpha jockey. 1 over b. I'm just kind of curious to see if Wolfram will know what I'm asking it to do. Minus 9x squared plus 10x. Plus 4. Dx equals 5. Oh, Wolfram agrees. It does know how to do this. That's kind of cool. Is it the same answer? 5 plus or minus root 13 over 6. Which one was it? That one? Yeah, all right. It's number 5 or number 1. Oops, I know I thought it was number 5 and number 6. All right. Let's get our DM. It's the SIR model person. All right, awesome. I need to drink some water. Okay, I'm really interested to look at the real analysis stuff from today. Because we ended on proving the mean value theorem, which was surprisingly short. So a lot of it is basically just Rolle's theorem, or Rolle's theorem does a lot of the heavy lifting for you. We didn't get to 5 or 6, so here's the function smiley face of x equals sine of 1 over x. Make a plot of this curve. I know what it looks like, but let's still do that. So it's kind of this very cool thing where at either tail, it kind of like just drops down to 0. But no matter how close you get to 0 here, like it just, the period is becoming shorter and shorter and just fluctuates faster and faster. So it's kind of a cool thing in Desmos, just like zoom, why can't I pan? Just like zoom way in on it, and no matter how close you zoom, it just becomes a wall of red because sine keeps getting like quicker and quicker and quicker. So I would say yes, it is continuous for the open interval 0, infinity. I don't see why not, basically. But it can't be continuous exactly at 0 because you have division by 0 and that's not defined. Like there is no function value at x equals 0, so it can't be continuous there. Function has to be defined. Calculate d smiley face of x by dx. This part of it, I know the only thing I knew about this going into it is what the graph looks like. So the continuity question, I mean, makes sense. My answer makes sense to me, but I don't know that it's true, or I don't know that I'm right. Let's try our hand at the derivative of it. Okay. So, I guess we can write down our answer for part B. Infinity not continuous. Okay. So then for C, D, oh my gosh, how am I going to draw this? D, smiley face of x by dx. So start by deriving the sine, which goes to cosine. Then you derive the 1 over x, which goes to minus 1 over x squared. So it's minus cosine 1 over x squared. So I've got to think it's differentiable everywhere but 0. I don't know why, like that's the only place where that seems invalid to me. If x's are negative, are there maybe 2 different derivatives for positive and negative sign? Or for like the positive part and the negative part? So like if we plug this in, if we plug a negative x in here, you would get cosine of a very small number, which is positive. I'm thinking for a very large and negative value. So yeah, cosine will be close to positive 1. On the bottom, you get a positive number. So the entire thing is negative, and it's very close to 0, which tracks for a very large value of x. So I think this is okay. I don't see why it'd be anything else, I guess. Before I move on to the next question, which is similar to this one, I kind of want to Google this. So I assume this is something that has been answered. Sine of 1 over x. Oh, should I have not used chain rule? Oh. Oh, interesting. Well, thankfully Zach didn't say to actually prove our response, but let's see what this is. Yeah, so we're showing that it has to be discontinuous at 0, even if you defined, if you manually define something for x equals 0. Do that by showing the limit doesn't exist. Okay. But epsilon equals 1/2. I guess if your limit doesn't exist, you get to choose your epsilon. And finding that there is no delta. The limit showing that for each delta greater than 0, there exists an x1, x2, and negative delta comma delta not equal to 0, such that f(x1 minus f(x2) are greater than 2 delta, or 2 epsilon. Why is it 2 epsilon? If you add it up, well, because you're going to eventually do epsilon equals 1/2. So the 2 epsilon is arbitrary. Okay. Let n equals ceiling 1 over 2 pi delta plus 1. Then you do inequality magic. I guess to isolate delta. That avatar music. Is this Avatar? Oh, yeah, the avatar is love. I didn't even realize that. Chill bending? What the heck? Wow, there's a lot. Oh, wait, I think I've heard of this. Dan might have mentioned this. Okay, it's an album by Sweet Boy Kyle. I don't know if that's simply a name. And the album's called Chill Bending. I guess it's Avatar themed music. It's kind of cool. One of the names? Yeah. You're so tired, but you still need to study? Oh, that sucks. Do you have tests coming up? Dude, I am having a hard time following this proof. Last exam for this half year tomorrow finally. Ooh, okay. Good luck. Okay, I mean, really, the reason that I Googled this was to make sure that the answer that I got was right, so it sounds like I am right. And so now part 6 is to repeat 5, but with x sine 1 over x and x squared sine 1 over x. I wonder why we would need a change of variables. I don't know why you can't just differentiate this directly. I guess let's try it and find out. I'll put it, yeah, I'll put it over there. Okay. Oh, that's the end of the playlist. What am I gonna play? We'll go to that one. All reliable. Okay. So that was for number 5. Down here for number 6, right? That's 6? Yeah. Okay, so we have x sine 1 over x. Oh, we do have to graph it. I'm gonna do that in Desmos. Okay. A little bit premature. Going to the board. Because it probably is important to grab it first, so let me do it in Opera. So I don't have to redo my Firefox. Ooh. What are you doing? It's like a... Oh yeah, this is more like it. Oh dude, this one's even cooler. All right. Does x squared sine 1 over x look like? A similar deal, but it I guess it's more spread out. Oh, and it like I feel like we've looked at this function before. This kind of thing feels familiar. Oh no, I think that was a different function that had the same like swoosh, basically. All right. I wonder if you can because that looks almost like a straight line, or it really just does look like a straight line. I wonder if you can find the equations for that. It's probably slightly curved, to be honest. You just can't tell that it is. But you seem to have an asymptote of like 1. Which... Is that confusing or does that make sense? Sine of 1 over x was approaching 0. For big values of x. So you have a very big number divided by a very small number, which comes to be 1. I wouldn't have guessed that, but I guess that's the rationale. All right. So is it continuous on 0 infinity? So for 0 infinity, 8? I think it's the same thing as here, and the same as with x squared sine 1 over x. I don't see, what's different about this function. Because you still have the same issue as just 1 over x. You haven't added in or fixed an issue by multiplying by x. It's a product rule. Oh, that's gonna get rid... Oh, no, we'll get rid of a discontinuity. It kind of... I mean, I don't know. So it's gonna be 1... over x squared, because you derive the inside, times x times... over x. I was thinking like you get rid of a discontinuity by getting x squared over x squared, but you don't, or x over x. And even though you still have a discontinuity from the inside. So this feels like it also has the same differentiability rule, just not at 0 and you're good. For very large values of x, we can do that same kind of thought experiment. For very large value of x, sine of 1 over x is sine of a very small number, which is 0. So you get 0 minus cosine of a very large number, 1 over a very large number, is basically 1 divided by a very large number. You get 0 minus a very small number. Isn't it supposed to... So you get a negative slope that's going to 0. Isn't it... shouldn't we have a positive slope? For a very large positive number? So I believe this function was increasing. Let's take a look at it again in Desmos. Yeah, it is increasing. The red one. Well, so is the blue one. This is gonna break Desmos. Whoa! Oh wait, so it is positive. Look at that amplitude. Why did I do it wrong? Topologist sine curves. They have some fun properties. Oh. Cosine of 0 is 1. I'm still confused why this is positive for a large value. Okay, let's go to Wolfram. Sine of 1 over, let's just say 10,000. Hey, Logical Insight, have you tried human benchmark tests? I have not. This is a negative number? Or positive? It is. Okay, wait. Sine of 1 over 10,000. Getting close to 0. Oh, but it's still somehow greater than the other thing? That's why? I should have just done the other part. Wait, so what is that? 4 zeros and 9s. 4 zeros and 9s. Oh my god. Well, yeah, but that's an 8 right there. And that's a 5. It's just barely bigger. I don't know what a human, like, what is a human benchmark test? Oh, it's like a brain game? I'm not super into these, to be honest. I feel like you can't really... It's kind of hard to quantify people like that. It can be fun, but I don't know, these are just kind of like, I'd rather just do math. They are fun. Those on your stream. All right, well, to be honest, I'm nearly done with the prompts for today. So then to quantify those, just fun exercise in between. All right, well, I just have this one little prompt here, and then, oh shoot, oh yeah, no, I am showing it, and then we can, maybe we'll try one, so we'll have some time after that. I don't think anyone's asking me a question in chat. I'm still not sure why we need to change the variables, but maybe we'll find out with x squared sine 1 over x. So, oh yeah, so where's this, shoot, where's this one differentiable? I think it's still differentiable everywhere but 0. For x sine 1 over x. So I don't see anywhere else where you have issues, I guess. So you have x squared sine 1 over x. For continuity, it's still 0 to infinity is yes. And that's no? I don't see what's changing between these, I guess. I kind of feel like it's always the same. Do another product rule. Oh, well, I guess here you do get an x squared cancellation. You still... It's still the same differentiability thing, though. Let's see what the derivative is like, but the names of the functions, I mean, yeah, those are different. Triangle and snowman, are those significant, or I assume you're just having fun with those? Oh, okay, okay. So the purple is the derivative, blue is the original function. So, okay, I was saying before, we can get the equation of this line, but it is going to be like ever so slightly curved, I think. Because the derivative is never quite exactly 1, even though it gets super close. Yeah, okay, the other thing is like the function, it does like the amplitude decreases a lot as you, or you know, it decreases infinitely as you get close to 0. But, and I was wondering if that should mean your derivative is also decreasing, but not necessarily. Okay. I assume there'd be some kind of harder like epsilon delta thing or some kind of like weird proof that we'd have to do as a part of this. I don't know if I would have gotten it, but I guess that doesn't seem too bad. Unless I'm missing something. I don't think there's a question from chat, and that was the end of the prompts from today at least, so. Maybe we'll do one of those human benchmark tests just for fun to see what they're like. Like, the aim trainer one kind of tempts me. The typing one too. 30 targets is quickly. I mean, there were only 2 more prompts from today. I mean, from previous days, there's certainly a lot that I've skipped. But at least the ones from like we only left 5 and 6 on the table, and I think I just did those, so unless there's some conclusion that I'm missing. "30 targets quickly can click the target above to begin. Bam, 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 bam." Oh no, I had a miss. Oh, they don't even tell you like wait the oh wait. Oh dude, I'm on the bad end of the bell curve. 534. Oh god, it's someone doing with a trackpad, yeah. Oh, they don't actually tell you how you compare until you save your score? $461, that's better. An AI bell curve. Oh, I'm still on the bad end of the bell curve though. I need to get good scrub about typing. Start typing to begin. Oh, okay, so you have to type the thing that's there. All right. Warm up my fingers. They're definitely cold. Okay. Ah. Ah. Fuck. Dude, these typos are killing me. Like 96 isn't bad. I feel like I can do better though. Oh, okay, this one I crushed. Wait, was I reading the bell curve wrong? Oh no, okay, for this one, no. The other one you wanted a lower score. Wait. The aiming one, do you want a low score or a high score? I wasn't even paying attention. This one is good because I'm at the upper end here. So previous desk job was stenographer? No, I mean, I don't know. It doesn't feel that, low score framing? Okay. I was taught to, like, type right as a kid with, like, home row and all that stuff. But other than that, it's just, having a life and being at the computer a lot. From 60? I mean, if I have to think, that's probably more like me. But if I'm just like copying down the words that are there, then I can go ham. Okay, 1, 2, 3. You have to speed run it too, that makes it more fun. Do it as fast as you can. What? Oh, it was that one? Oh. Oh. Ah. Okay. Oof. Definitely heating up. Oh, that one? I'm missing one. Yeah, I'm guessing now. Oh, I'm missing another one? They do not give you a lot of time. I barely even saw this one. No. No? No? Oh my god. That was the thing off. I already forgot what was thing in the upper right. Nah. Alright. 14? That's interesting. There's like a little peak there. Alright. Guys, just like little games. I mean, this is a potential like we're trying to think of like things like Pi Day, like even something little like this, just having some kind of like different categories of like little competitions could be fun. I'm trying to think of like things that we can do. It's like, you know, there's like any game that has like a scoring, like the first one's like 314 points or something like that. I don't know. It's something that's like been on my mind for like things that we could try and figure out. Or even like we're talking about like a Portal. I feel like I've heard a couple of the others mention like having and liking Portal, so it could be cool to do some kind of like thing in that too. But I don't know. I'm still trying to like have a fully formed thought. I don't really have one yet. Has anyone gotten back to me on my Reddit replies? No. I guess we could look at what were the previous weeks or previous like real analysis prompts. I think for the last few sets, I think I've done them all. Or maybe not the last few, but at least last one or two. So let's look back at what is today's Thursday? So look back at Tuesdays. I feel like I did these. Yes. I remember doing this one last time. Number 8. This is last Thursday. Oh yeah, I was having fun with these. I think I've done all of these. Did I do all of these? I think, yeah, I did. What about 13? Oh, I didn't realize that we had that one before. I haven't done 7. Oh, what's up, Emiliano? Put it on Discord. Oh, shoot. Sorry if I missed it. Yeah, post your question. You can do it in Discord. Or you can type it out there if you want, whatever's easiest. I'm out of water, so while you're doing that, I'm gonna go get some water. But I'm happy to answer your question. Oops. Keep running over my headphone cord. All right. I was cut the top part because I don't know how much you want to like. Show, I guess, but the next exercise is 1 to 5. Evaluate the function f and the point u. Oh, really? That's a vector. It's kind of funny that vectors are called points. Or maybe it's two meanings like that, but either way. Okay. Oh, they're gonna get it a lot harder, but so working our way through these. So Emiliano, do you need to see all of these or just a certain one? Well, I'll wait to hear back from you, Emiliano. I'll start with the first one, but if you want to see a certain one, just tell me which one. Oh no. Goodbye, markers. I hardly knew ye. Okay. Wait. Let me see. All right. I didn't hear anything back from you, Emiliano, so I'll just work through them in order, I guess. So the first one, with x1, x2, x3, x4 is x1, x2 minus x1 squared, x4 minus 2x1 minus x4, x2. Actually, I'm not going to do those. I'll do parentheses. Minus 1, 2, minus 2, 3. Right? Okay. So Emiliano, to do this first one, you just plug these numbers into the x's. So -1 will be your x1, 2 will be your x2, like x1, x2, x3, and x4. Just plug this in for the x1s, that for the x2s, that for the x3s, that for the x4s. Looks like they'll get a little bit harder, but for this one, you can just plug things right in. So x1 is -1, x2 is 2, x1 is -1, x4 is 3, minus 2, x1 is -1, minus x4 is 3, x2 is 2. There were no x3s, that's kind of funny. But okay, that is what it is, I guess. So that's -2. That's -3. That's +2. That's -6. That's -9. So does that make sense for the first one, Emiliano? Like how you're supposed to do a problem like that? Yeah, Stooky. I know I'm gonna be going for a ton longer, but just kind of depends. Um, all right, so Emiliano, I need to hear how you're feeling, I guess. Are you good with this first one? Maybe I'll try asking you in text on Discord. Still not. Oh, okay. So you type back on Discord. Okay. Oh, I didn't even think to check my answer against that, but -9 and -9. Okay, good. You got 100. Oh, nice. So wait, Emiliano, are you here in the stream or? No. Did you see it? Yeah, Emiliano, I just went through and did the question. I'm trying to figure out if you actually saw me do it though. Okay, you can type in YouTube too. I was just trying to get through to you because I wasn't hearing anything back. Okay, I want to make sure that you're okay with the first one before I moved on. If you're okay with the first one, um, I'll move on to the second one. So what do we have here? Oh, all right. So yeah, we're already ramping up in difficulty a little bit. It's the same exact idea though. It'll just look a little bit different. Is it getting a little bit dark, by the way? I think it's okay. So now we have f of x, y, z is root 1 plus x squared. Why is there no z in this one? Oops. I just put my own z in there. And then our direction is x minus y. I guess because we will get a z. It's so weird to show like that though. X minus y, x plus y. Oh no, we still get a z. 2 minus z. Okay. That is what it is. So this is the same exact procedure as last time, but we have some variables instead. Basically, this is our first one. So it's going to be x minus y. Wherever we see x, we do x minus y. Wherever we see y, we replace it with x plus y. And wherever we see z, we do 2 minus z. But weirdly, there is no z, so we won't have to worry about that. So f of x minus y, x plus y, in 2 minus z is root 1 plus, now we see an x, so we have to do x minus y instead. Plus, now we see a y, so we have to do x plus y instead. And I assume they want us to simplify this. Yeah, they do. Now we have to do some multiplying out. X minus y squared is 2x minus 2xy plus y squared. It's too ambitious closing out that square root there. Plus x plus y squared is x squared plus 2xy plus y squared. All right. That should be x squared. Why did I write 2x? There we go. So that one is still there. X squared plus x squared is 2x squared. Minus 2xy plus 2xy is 0. Y squared plus y squared is 2y squared. So that's how you get the answer that they gave. Are you okay with that one, Emiliano? Or do you understand what I did there? Yes, exactly. I'd say the z is a trick. There is no z anywhere in the problem. So I don't know why it's there except to confuse you. Okay, awesome. I'm happy to. Do you want to see like 3, 4, and 5 as well? I'm happy to try and work them out. But unless if you're already okay with them, then I'll leave you to it. But it's up to you if you want to see the next ones also. With 4? Oh, you want to see 4? Yeah, it does look a bit harder. Those are in the house. Oh, yeah. I'm sure you're gonna narrow down my exact location not after long here. Actually, I'm looking at the reflections, and it's kind of hard for me to even tell just based off like what I'm seeing in the stream. The whiteboard reflection is probably the most helpful one. Well, even then, I don't know. Cheapest location, yeah. All right, so actually, I need to actually look at number 4 before I go to the board. So what happened with 4? We have a sum of a product from I equals 1 to k. Oh, okay. This will be an interesting one. I see where this is going. I need to figure out how I'm gonna explain this in words though. Okay, I think we're just gonna try some examples so I can show you the pattern. The blue. How do you even? I've never have to draw these by hand, though. Okay, I guess like that. Wait, was that k? Okay, yeah, k equals 1 to n. I guess I'll draw it like that, capital pi. Is that I equals 1 to k? X sub I. Then U is 1, 1, 1. Two. Just to throw you off. Okay. We're expecting n plus 1 as our answer. Really? N plus 1. I thought it would be n plus 2. No. N plus 1. Okay. I get it. I think. Okay. So, Emiliano, for this one, let's try an example. I think an example is going to make this a bit easier to see what's going on. So, so I'm just going to take n equals 3 for our example, and then hopefully we can build from that example to figure out what kind of the problem is doing in general. So k equals 1 to 3, I equals 1 to k, x sub I. Okay, so this notation is very confusing. You know, it's a lot to look at, but this is like, this means you multiply and this means you add, basically. So, how should I express this? I'll show how we kind of get this part in the middle here. So we start, I guess we start from the outside. So when k equals 1, that means we have the product from I equals 1 to 1 of x sub I. And so now we plug I equals 1 into x sub I, and that's just x1. And then we only go up to 1, so we're already done there. And we're done with this product, so we're done with k equals 1. Now for k equals 2, we have the product from I equals 1 to 2 of x sub I. So we start at I equals 1, we do x sub 1, and then remember this means product, or you multiply, so then we increase I by 1, and we multiply in x sub 2. And now we've hit 2, that's our endpoint, so we stop here. Now when k equals 3, go I equals 1 to 3, x sub I. Same procedure, start with I equals 1, plug it in for I. So you get x sub 1, product, so you multiply in the next thing. Now I equals 2, so we get times x sub 2. Now you multiply again, x, now I equals 3. So you keep increasing I by 1 each time. So I hope you're with me so far with this little example. Oops, we have another step we have to do after this. So we've done all of these products like just inside this section here now. We have to remember that we had the sum out here, so we have to add up all of these results. So we get x sub 1, that first one, plus, because we're summing, x sub 1, x sub 2 from there, and then plus the next one, x1, x2, x3. So no matter what our n is, we're just going to get this kind of, it's always going to be x1 plus x1, x2 plus x1, x2, x3. And if your n goes even further, you know, x1, x2, x3, x4, and then you multiply it in x5 and x6, all the way until you get up to your end value n. So that's all this pattern means. And I think it's important to kind of understand why that pattern is the way that it is. Like, you know, what this actually means in like with like a practical example. It also means when n equals 3, u is 1, 1, 2. Because that has to have 3 things in total. We know it's 1 repeating until you end with a 2. So you get 2 1s and a 2. Because it has to have 3 things. So we can figure out what that is. Because remember, 1 is x sub 1, that 1 is x sub 2, and the 2 is x sub 3. So we can plug it in over here. So we'll get 1 plus 1 times 1 from there. Then we get 1 times 1 times 2. So it's 1 plus 1 is 2, plus 2 is 4. You'll notice we started with n equals 3, and we get 4 as a result. Let me check the chat again, see if you've written anything. You got it until that point. Oh shoot, until which point? This is not an easy problem, so I want to make sure I don't... Everything is correct? Okay. You got it? Oh, good, good, good. Okay. Perfect. Okay, so I'm glad that you're with me with this little example here. So we kind of need to extend our thinking now. We need to make a pattern out of this and think about, you know, we don't have n equals 3, n can be anything. So kind of back to reality with this pattern, I'm going to kind of expand this out just to make the pattern a bit more clear of what's happening. K equals 1 to n. Product equals 1 to k. X sub I. x1 plus x1, x2 plus x1, x2, x3 plus x1, x2, x3, x4, okay, and then I'll do the dot dot dot, plus x1, x2, dot dot dot, xn. Okay. So this is the exact same thing as this. I just wrote out some more of the pattern. And just like how here we had 1, like these were all 1s until the very end. And we're all, like, because we're given this u, everything was going to be ones until the very end here. Like that x sub n is going to be the only 2. So no matter what our value of n is, we always have 1 plus 1 times 1 plus 1 times 1 times 1 plus 1 times 1 times 1 times 1 from those plus dot 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 plus 1 times 1 dot 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 2. And 1 times 1 is always just 1. So you'll get 1 plus 1 plus 1 plus 1 plus dot 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 plus 2. And that's going to always be your pattern here. Just like it, it works for this example we did with n equals 3, and it's not too much of a stretch to see, like, it's going to keep that same pattern, I guess. I say the word pattern a lot. So we know how this behaves in general now. It's always, you're just adding a bunch of 1s and then a 2 on the end. We still need to figure out exactly how many 1s and how many 1s we have. So I think the easiest way to think about it, for me at least, is this kind of does the counting for you. You go 1, 2, 3, 4, n, or like, 1, 2, 3, 4, 5, 6, and then all the way up to n. So you have n minus 1 ones. And that's because your nth term is going to be that 2. So you have n minus 1 ones and just 1 2. Because there's n many terms in total, and all of them except for the very last one are always 1. So if you do 1 plus 1 plus 1 n minus 1 many times, they add up to n minus 1, as it turns out. I should have a better way to explain that though, right? You're adding 1 n minus 1 many times, so they add up to n minus 1, I think is how. So if these ones all add up to n minus 1, and that 1, 2 is just 2, then this entire string of 1s adds to n minus 1, and that 2 is still there. So you get n minus 1 plus 2, and of course you can simplify that to be n plus 1, which is our answer. So please let me know if that makes sense. I hope it does. It's kind of a hard one to explain, so. Number of 1s is equal to n. It's equal n minus 1. You probably said that a few minutes before I said that out loud, but actually my webcam's in a bad spot, isn't it? So I'll take my webcam back down so you can see the entire board. You love the way I explain things. Thank you so much. Oh, hey, well, no problems at all. Emiliano, I'm really glad to have helped you. Thank you for the questions. If you want to see any videos on that sheet or any other questions in general, just let me know. The rest you'll do on your own? All right, perfect. Got a test tomorrow. Ooh, well, good luck. The explanation is better. No problem. I'm glad to have helped. Um, all right, so I never looked at all at oh gosh, this one looks a little complicated. Yo, Star. I'm doing good. How about you? Do you know science? I'm not very good at science, unfortunately. I don't feel confident enough to really answer questions and know that I'm not giving you bad information. So I'm sorry about that. Prompt 11-9. Where is it? There it is. Oh, yeah. This. I definitely didn't do this one. Every open cover of a set has a finite subcover. This one feels a little bit easier for me to think about than the other continuity topological definition. Every open cover of a set has a finite subcover. Let's look back at our definition of cover, though. Well, okay. A compact set is closed. An open cover of a set is, I assume, made of open intervals. So how do you possibly include your limit points? Oh no. This doesn't make sense to me at all. How can you have open sets covering a closed set unless the open sets like spill over? Like, I'm gonna open up Paint because I feel like it'd be a little bit easier to do this stuff in Paint right now. So I want to be able to like copy paste the definitions and have everything in one spot. One moment. Okay. So in the section, use X as a subset of. Oh, okay. Perfect. That answer that addresses it. Thank you, Stuki. So I assume that was section 2, and I don't think we had that discussion in section 1. Okay. I should still think this through because why wouldn't an open set? How would an open set violate this? It's a finite subcover. So cover of a set, a collection of sets, finite or infinite, E sub I, such that X is a subset of the union of E sub I. So if we have the compact interval 1, 2, one, two, we could make a cover of this, say, 0.5. Well, and I guess I'll say like 1.6 and 1.4 to 2.5, you know, just so we could say that 1, 2 is a subset of, you know, it's not a very efficient cover, I guess, but union, oh, that's not 0.5, 1.6, 1.4, 2.5. That makes sense, but what? How is an open interval excluded from this definition? Like, why can we not do the same exact thing? Oh wait, every open cover of a set is a finite subcover. Is there an open set that does not have a finite subcover then that covers this? I guess that's the key. I was thinking just one, but we'd have to say every open cover has a finite. Well, actually, I'm not even looking at the finite subcover part. I should before I even think about that part. Okay, what is the every open cover set has a finite subcover? So a subcover is just a further division still of that cover. So my subcover, oops. Oh my God, how does Dan do it so quick? Like I could just like, you know, split these two things in half again, and that's my finite subcover. Or yeah. I'm not going to write out 4 different intervals, I guess, but I think that's the idea. Every open cover of a set has a finite subcover. Oh God, now it is getting dark. Let me turn a light on. Okay. So, well, I guess I could start with the easier case, which is if you have, so if something is compact, it is closed and bounded. I'm looking at something that is not closed. If something isn't bounded, I think the answer is pretty simple, where good luck naming, well, actually finite refers to the number of sets. So I guess maybe this isn't the easy case. Because this is a finite cover. Oh god, I might need to Google this because I'm like, because even though there's infinity inside it, that's not what the infinite or finite thing is referring to. The open cover of a set has a finite subcover. So this has a finite, like this cover, we could name another finite subcover. So maybe I made a bad choice of my initial cover. I need to Google this. I don't see the strategy here, I guess. The only problem covers compact doesn't necessarily have infinitely many open sets. Okay. Okay. Maybe I want to keep on thinking before I turn to Google. Do you want to have finally made sense? You can just take the cover itself. Okay, yeah. So if it's unbounded, we could take the cover like n how would we do this? Every open cover. Okay, so okay, yeah, the initial cover that you choose could be infinite. Even an infinite cover has to have a finite subcover. Huh. I think I need to go back and think about that part for closed sets, but let me just continue my train of thought here. I equals 1 to infinity. You could do, say, I minus 1, comma, I plus 1. I mean, isn't this still... This still just expresses the idea of like 0 to infinity, and you can surely... So I don't think I'm naming the right finite... I don't think I'm naming the right infinite cover here. So maybe... You have to be able to point out a problem with the boundedness. You have to be able to point out a problem with the openness. So maybe is maybe for 1, 2 open, can we say that's a subset of if we want 1 plus 1 over I, 2 minus 1 over I. And that, I don't think that has a finite subcover. Well, what's our definition? Well, I mean, it refers back to the original X, though. Because like this is still expressing 1 comma 2, so why, like, I guess I'm struggling with like, why can't I just add another thing in the chain of like 1 comma 1.5 and 1.4 comma 2? Because it's still all referring to 1, 2. So I feel like, you know, you can't express this idea of getting like very close to 1 and very close to 2 in finite terms, but it still is bounded. All right, I think this is a Googler. Wait, this is a proof by contradiction. What was Q2? Are there different proofs? Oh, okay. Let O be an open cover of 0, 1. Okay, so for any x, you go from 0 to x. You claim that as a finite subcover from O. I already don't understand this part here. A has finite subcover from O? Hmm. Take any U1, U2, UN. Hmm. This is feeling like gibberish to me, because like, I guess it would make sense if the subcover has to have some relationship with the cover, but I don't see why. I guess, oh, am I just... It's because of that. Okay, that's what I was getting stuck on, I guess. For some reason, I forgot about this. It has to be a sub-collection? Or no, just F1 is a subset of E1. Each of them individually must be a subset. Okay. Like on a turn-by-turn basis. Okay. So that's a connection that I just made. You can't just do anything you want. Wait, that the entire thing? Well, that confuses me because couldn't you say that each f sub I is some e sub j? Okay, not necessarily like term by term, but like you don't need all the e's in the subcover. Okay, so f sub I could be shrunk, I guess, like if I guess that's like E1, E2, E3, you could have F, like your F1, like just not go out, like just have that like gap there that you're not addressing? Is that what you're saying? Curious Tree has no proper subcover. Okay, well, that's a problem. Throughout any of the E sub i's, you have a gap. Oh. Then I don't understand what a subcover is. That's the problem. If you throw any of the E sub i's, you have a gap. Hey, Sophie. Shrink the E sub i's, give the F sub j's. You're allowed to choose some to exclude. Yeah, closed and bounded. And so at first I was off to the races trying to figure out the actual answer to question 9 here. And then as I tried to figure it out, I realized that I apparently have no idea what a cover or a subcover is. So I guess I need to maybe find some examples of what a cover of a set is and then a subcover. I thought I had an idea, but evidently not. I don't know if I want to look at Wikipedia. Okay. PDE? Really? You need covers for PDEs? Contained within another cover. U1, U2, U3 covers X. Let's say it happens to be the case that, hey... Oh, okay, so that's what you're saying with not being able to throw things out. Okay, so the idea of subcover is if you have a redundant, like a redundancy in your cover, you can throw out that redundancy, I guess. Oh, okay. Now I guess I see where it's starting to go a little bit. So, all right, let's try and redraw this out. So, I guess we can do 0, 1 to be like the cool kids. Even though it's not that important, I just care more about cover versus subcover right now. I said 0, 1 and I wrote 1 and 2. Okay, we won't be like the cool kids. So our subcover, let's just say it's like if we need to build in a redundancy here, I guess we need to do let's put it up top. 0.9 up to 0.6. Then 0.5 will be efficient and say like 2.1. We need something that's redundant here. So like, let's just say 0.8. Can it actually be past 2.1? Or does subcover have to be completely within the initial cover? No, I don't think the subcover has to be completely within the initial cover. So I can make this other one like all the way out to just say 3. So I'll say my cover is 0.9, oh God, comma 0.6. Wait, that's not how number. Wait, oh my God, 1. This is terrible. I forgot how to make number lines. Okay, so 1.6 union 1.5 2.1 union 1.8 3. The loss of generally may assume the subword train improves topologically compact is the unit interval. Okay, yeah. How the argument goes. Curve's been kind of weird. I think of an example. Cover of the rational numbers that is not a cover of the real line. Interesting. I don't know exactly how that would go, but I can imagine that something like that is possible. Okay, and so for our subcover, how with my new interpretation, you just chop off something that you don't need. So like, all we need are these first two. So we can just chop off that last one and say that our subcover is 0.91.6. It's not necessarily the most efficient, but it is like more efficient. Okay. So now that I hopefully slightly understand what a subcover is, an alternate definition of compactness set is used. Every open cover set has a finite subcover. Let's get rid of this. Okay, so I guess now we'll be up the cool kids and look at 0, 1. I guess maybe it's more interesting to me to do the ones that don't work. So every open cover of a set has a finite subcover. Yeah, you do be careful how you kind of choose your cover here. So if I propose the cover, let's just say 1 over I, comma 1 minus 1 over I, you could just take, well, wait, this might actually work. I was thinking that you could just like take some very large value of I or something, but that wouldn't actually cover it. So maybe I did just name something that doesn't have a finite subcover. Let's see what you're saying, Sophie. You pick your favorite bijection between the rationals and positive integers. Okay. And the first rational, pick an interval of length 1/2 that contains it. Around the second, an interval of length 1/4. Around the third, an interval length of 1/8. The total measure of all those intervals is 1, so there's no way it covers the entire real line. Probably covers every rational number. It's definitely not helping me out immediately, but maybe I'll come to some realization with that. I don't know. I'm still just like struggling with my with the basics right now, I guess. So, okay, I guess I thought this wouldn't work. Well, I didn't make any redundancy in this, I guess. Which, it still doesn't have a finite subcover. Let's try a different one, I guess. Like if I have one intentionally with redundancy here. -1 plus 1 over I. And 2 minus 1 over I. So it approaches -1 comma 2. this one does have a finite subcover that would cover 0, 1, though. You can even take I equals 1 and you're done. So that one's no good. But this, like, I guess, minimal cover, if I can call it that, seems to work. I can't think of a reason why not. Okay, and I think it's kind of similar to what the ideas I was seeing on Stack Exchange with kind of just barely covering the interval. I think they were doing something more along lines like 0, what is it, like I over I plus 1? Which definitely approaches 1 from below. So maybe I have the same type of idea, but just a different execution of it. I don't know, at least I hope. Okay, so that's a problem with an open interval. What about an unbounded interval? What's the problem with that? It's a weird infinity. So what's a cover that we can name here? It's a finite subcover. I mean, couldn't we just say 0i? Because I got to think that's going to cover 0 to infinity, because it does grow without bound. And can you name a finite subcover? Yeah, I think this works. Okay. You know, and if I can't poke a hole in it, then surely it's right. Okay, so I can see why these ones don't work. Can I see why 0, 1 does work? So if I took my, like, one here and I just made it close, what happens there? Covers need to not be countable. Represent an arbitrary cover. Oh, really? I assume I could still use this idea. I would seem to phrase it differently. Like, instead of, like, I guess indexing on the natural numbers, would you, like, I don't know, do like a 0, 1 or something like that? Over an indexing set. Or I guess, yeah, 0, 1 is stupid, but I guess 1 to infinity, right? I mean, good luck trying to, you know, plug every real number in, but that's not our problem. Is that a more accurate way to say this? Hopefully. Let me just retype that. It's not from that exact cover. Oh, so even then, for the one that I named for, like, the counterexample, that's fine. But for every open cover to actually prove that, you do need to be careful of that. Okay. Yeah, I mean, first one, I was just, I'm just trying to explore this before I try and actually prove anything, I guess. I just want to see, like, for something that is compact, why does this one apparently now work? Hopefully. If I did this right. Oh wait, this isn't an open cover. This already doesn't work. Oh, then maybe that's why this doesn't work. Because the bad example down here. Oh, so you have to give it some redundancy. Okay. Well, you can stay there. So yeah, like an open cover you could name is like that. But this one, like, you can just take I equals 1 and you're good. Okay, so as for examples that I could think of, you know, this thing seems to check out. You don't get to pick the open cover, even with this mathematics. Yeah. But yeah, that feels like how people were describing like epsilon with epsilon delta proofs. But no, I'm not saying this is a proof. I'm just saying that like the thing that I did here is just like an exploration. I would not call that a proof. I just wanted to apply like the counterexamples that I made here, or not counterexample, you know, why an open or unbounded set isn't compact. I just wanted to apply the things that I made there. To something that is compact and just see why these no longer work. Now actually showing that seems, I still don't know how we like prove this. I imagine I've found the idea by doing this little exploration, but kind of like getting to that idea in a rigorous way is hard. So maybe I should just look at a proof on Google. Okay, so this was not it. Proof closed and bounded set. I don't know. Every open sub cover, or every open cover. Let's just see what comes up with this, I guess. Only one direction in the implication. All right. Oh, this is what you're mentioning, Sophie. Ein Borel? Probably not saying it right. Oh yeah, okay, we got to the same exact spot. All right, so if set is compact, it must be closed. I thought that's how it was. That's how we defined compact. Oh wait, no, I see. Never mind. They're proving. They're proving that this implies that in two different proofs, I guess. Okay. If a set is compact, it must be closed. If A is the limit point of S, then any finite collection C of open sets, such that each open set U belongs to C, is disjoint. Oh gosh. Okay, so it's just saying that your cover has to contain the limit points. Or if A is the limit point of S, any finite collection C, okay, so I'm not necessarily your cover, but just a finite collection C, open sets, each open set U belongs to C is disjoint from some neighborhood V sub U of A. Okay, okay, so if you're, it's only a cover if C contains A. Or it certainly can't be a cover if C does not contain A, I guess. Not say that it is a cover. And since A is an arbitrary point, I guess, okay, you need to include your limit points, I guess. Indeed, the intersection of the finite family of sets V sub U is a neighborhood W of A and R. Okay. Yeah, I was getting tripped up on, like, they had a collection of open sets, but it wasn't necessarily, they're saying when it is or isn't a cover, I guess. And I was, as soon as I saw a collection of open sets, like, oh, it's a cover, but no. The intersection of the finite family of sets V sub U is a neighborhood W of A and R. Some of the cover that contains that point. Okay, that's a nicer way of saying it. Yeah. The intersection of the finite. I thought V sub U specifically disjoint from the neighborhood V sub U. Okay, never mind. Neighborhood W of A and Rn. Okay. Should cardinality of any cover equals 0, 1 to that of the reals. You have to go from the real countables and countables to the finites. All right, I guess we'll see. Since A is the limit point of S, W must contain a point X in S. W is our neighborhood of A. Okay, yeah. It's saying that W is at least a little bit in S beyond just the limit point. Because you don't, I guess we're not dealing with singleton points. Probably need to assume the axiom of choice. Okay. We haven't even touched that in real analysis, but I'm just gonna, I guess, take that at face value and not worry too much about it. This X belongs to S and not covered by the family C. Because every U in C is disjoint. Because every U in C is disjoint from V sub U, and hence disjoint from W, which contains X. Is this a contradiction? Oh. Okay, so it's a proof by contradiction, which I wish I said that earlier. Assumes the axiom of choice, which assumes it's allowed. Okay. If it's compact but not closed, has a limit point A, not an S. Consider collection C prime consisting of open neighborhood N of X for each X belongs to S, chosen small enough to not intersect some neighborhood V sub X of A. Okay, what is that saying? If you need to choose a set C that covers some point X, there might be an infinite number of such sets. Pick one such set for every point X in the interval. Oh, okay. Yeah, I know very little about the axiom of choice. Other than it can apparently lead to weird results when you do assume it. But I guess that's why we would need the axiom of choice for this. C prime is an open neighborhood N of X. For each X belongs to S, chosen small enough to not intersect some neighborhood V sub X of A. Small enough to not intersect some neighborhood V sub X of A. Okay. Then C prime is an open cover of S. Well, if you're specifically avoiding A, how are you possibly covering S? Oh wait, A is a limit point of S, not necessarily in S. Okay. We haven't established that. Okay. Then C prime is an open cover of S, but any finite subcollection of C prime has a form of C discussed previously, and this cannot be an open subcover of S. C prime is an open cover of S, but any finite subcollection of C has a form of C discussed previously, and thus cannot be an open subcover. Oh. Okay, so they start by establishing it. You can't avoid your limit point and still be a subcover. And then we tried to name a cover that avoids limit point and figure out that there can be no such thing. So I mean, this part didn't have anything to do, or it didn't. So I thought this was like a contradiction at this point for some reason, but okay. So I was jumping the gun that, you know, A is the limit point of S. We don't necessarily know that it's in the set though, because we're trying to prove that it's closed. We haven't established that it's closed yet. So you have to get within, you know, an arbitrary neighborhood of A without actually getting to A in order to cover it. Well, yeah, in order to cover it. Or rather, you have to, I think I'm phrasing it wrong, but I feel like I'm starting to get the idea of this. A is the limit point of S. Okay. I definitely need to like come back to this like another day and go over it again, but I think I kind of get what's happening with this. So that's for the closed part of the definition of compact, but we also need to do the bounded part. So I guess let's see what this is. The SBA compact set in, and I'm not considering the multi-dimensional stuff, I'm just treating this as one-dimensional. This one looks a little bit multi-dimensional though, so might have to look for a different proof if it's too weird, but maybe we can make sense of it. Let S be a compact set in Rn in use of X be a ball of radius 1, which I understand to be an interval with radius 1, centered at X belongs R to the N. S is a compact set in Rn, U of X is a ball of radius 1, centered at... Okay, so for some X, you're taking 1 minus at X and 1 plus at X. Set of all such balls, I'm gonna giggle every time I see balls. Set of all such balls centered at X belongs to S is clearly an open cover of S. What? Oh, so that X belongs to S. Okay. Oh, shoot. I don't have that set up, Sophie. The one that's playing right now is, oh God, it has like a little bar over the E. So I'm typing it out for you. But the first E in Reeve or whatever has a bar over it. And I can't like copy paste it. And I'm definitely not listening through Spotify because that would violate their terms of service. But I heard the playlist, this playlist on Spotify is just like the one that I'm listening to. I'm definitely not playing it through Spotify though. That would be horrible. Set of all balls centered at X. Long says. Okay, so you're taking every interval of radius 1 at every point in S. It's clearly an open cover of S. Okay, I can buy that. Since S is compact, take a finite subcover of this cover, right? This subcover is a finite union of balls of radius 1. Consider all pairs of the centers of these finitely many balls of radius 1. Let m be the maximum of the distances between them. Okay, so we're going to bound the distance between the centers of these balls. And that's going to show boundedness, I guess. If C sub P and C sub Q are the centers, respectively, of unit balls containing arbitrary PQ belongs to S, the triangle inequality says the distance between P and Q is less than or equal to the distance. Ooh. Between. This is a different version of the triangle, or a different format of the triangle inequality that I'm used to. So, I mean, distance, we can still, for one-dimensional, we can treat as absolute value bars, I guess. Oh, they do some fancy plus minus. Oh, I get it. So they take absolute value P. We can draw this out on paint. Okay, so at least talking about like one-dimensionally, they start with the distance between P and Q, absolute value. They say it's equal to absolute value P minus C sub P plus C sub P plus C sub Q minus C sub Q, not minus, minus Q. So all this stuff here adds to 0. So you haven't actually changed anything. And then you triangle inequality, I guess, 3 times. Or, well, twice. You take that as a pair. P minus C sub P. You take, you're going to want, so you have minus Q, so you're going to want plus C sub Q, which leaves you with C sub P minus C sub Q. Plus, now you want your Q minus C sub Q. Okay. I don't really going after this, but I just need to like unpack that little bit there for one-dimensional case that we've been working on. Contained within some finite set of unit intervals. Yes. So I've been trying to interpret it, at least. And we defined M to be the maximum distance between them. Okay, yeah. So then the next stage is, this is from P to C sub P is less than 1 by definition of this ball of radius 1, or interval of radius 1 for our purposes. Same with C sub Q comma Q. In the distance from C sub P to C sub Q, we define to be, well, the maximum of that is M, so we less than or equal to it again, and we get that P comma Q is less than or equal to M plus 2, which is a bound. And P and Q are any arbitrary members of S. Okay. Once you get past, like, you know, once you boil it down to like the one-dimensional that I'm used to, this one feels much easier for me to grasp than this one up here, which I think I'm starting to, but I'm not there yet. Okay, so between these two proofs, I think we proved going from here to here, and now we need to do the opposite direction. So if it says closed unbounded, then it is compact. An N box? Oh. Is that a closed? I guess I'll treat it as a closed interval. Okay. If set S and Rn is bounded, they can be closed within an N box. And I guess it means the beginning point, since n equals 1 here. Okay, yeah. And I guess the the endpoints are like, I guess complements or, you know, negations. It's the same number, one's negative, one's positive. For a greater than 0, above is enough to show, oh, I shouldn't have skipped the lemma, I guess. Oh, by way of contradiction, I know it's Enigma's favorite. A closed, well, actually, what does lemma at least say? And then we'll keep going through this proof. Closed subset of a compact set is compact. Closed subset of a compact set. Okay. Yeah, that makes sense, I guess. Without digging deeper into the actual proof of it. By lemma above, it is enough to show that T sub 0 is compact. A closed subset of a compact set. Okay, so we're naming a set we know is compact. And we know that S, or we're going to say that it's closed, or rather it has to be closed in some way. Okay. Assume by way of contradiction that T sub 0 is not compact. Then there exists an infinite open subcover C of T sub 0 does not admit any finite subcover. Right. Through bisection of each of the sides of T sub 0, the box T sub 0 broken with 2 to the n sub n boxes, each of which has diameter equal to half the diameter of T sub 0. Okay, let's... Bisection of each of the sides of T sub 0, 2 to the n sub n boxes. Okay, so we're just splitting it into powers of 2, like arbitrarily big, like, you know, halves, quarters, eighths, sixteenths. Then at least 2 to the n, at least one of the 2 to the n sections of T sub 0 must require an infinite subcover of C. Otherwise, C itself would have a finite subcover. Okay, yeah. This is based off the contradiction. This feels like shades of Bolzano wire stress. Like cutting things in half and taking the like infinite part in the Bolzano wire stress. I don't think it's contradiction. The sides of T sub 1 can be bisected, yielding 2 to the n section T sub 1. Oh, wait. Oh, not arbitrary, not powers of 2. This is, for the n is the dimension. Okay, so we're only bisecting it. We're not doing like eighths. We will continue bisecting it, but at this point we've only bisected it once. Okay. And this phrasing is a little bit weird because they're doing things for an arbitrary number of dimensions, and I'm not. Okay. So T sub 1 can be bisected, yielding 2 n sections of T1, which for me is just 4 in one dimension. So which would require an infinite subcover of C. This manner yields a decreasing sequence of nested n boxes, right? Length of side T sub k is 2a over 2 to the k. Okay, so it's just the width of the interval. Oh, okay, yeah, I mean, yeah. That's expressing the halves, quarters, eighths idea. Let us define the sequence f sub k such that each x sub k is in T sub k. I'll come back when we have to require an infinite subcover. Okay. Let's find a sequence. Oh, we do bring in sequences. Let us define a sequence f sub k such that each x sub k is in t sub k. Okay. This sequence is Cauchy, so it must converge to some limit L. Yeah. Because it's bounded, so it's Cauchy. Since each t sub k is closed, and for each k the sequence x sub k is eventually always inside t sub k, it's always inside t sub k, yeah. The L must belong to t sub k. Okay, yeah. Since, oh, let me see what you're saying, Seppi. Made up a sequence of intervals all nested. Yes. In this sequence, at some point x, or which we know is that C exists. Okay, I guess we're about to get to that. Since C covers T sub 0, it has some number U belongs to C such that L belongs to U. Since U is open, there is an end ball, oh god. B of L is a subset of U. Oh, just some kind of ball around L. That's a subset of U. Okay. And because it's open, yeah, you can always name things just a little bit closer. Okay, okay. For large enough K, one has T sub K is a subset of B of L is a subset of U. Okay. For large enough K, even numbers of C need to cover T sub K can be replaced with just one, U. This is where it's losing me. All right. For large enough K, one has T sub K, a large enough K. I feel like it should be a small enough K, or big enough ball. Maybe look at what you're typing, Sophie. Which we know set C exists if the set C is open, so it must contain the entirety of one of our intervals. Of K, T sub K is small enough that it fits inside. Oh, I had that backwards. Oops, you're right, you're right. I was thinking like a large enough, I was thinking about the beginning for a large enough K for some reason. Rather, it's over at the end where it gets very small. Okay. Fits inside, okay, and that's a subset of U. Then the infinite number of members of C needs to cover T sub K can be replaced by just one, U, a contradiction. Where each object is, whether it's a number. Okay. Okay, so the purpose of bringing things to limits here is so we can name our own set. Why is U open again? We're trying to name our own set that makes this finite. And so we did that by naming an interval around L, or a ball. that encompasses basically everything after it. All the bisections after it, or around it, I guess. Oh yeah, use just an arbitrary. Annoying parts of math, we can still be a little creative. Paint C cover, C sub I for sets uncover, X for a point. Something that contains X. Okay. Yeah, I definitely. There's a lot of letters being thrown around here. I guess I haven't done enough of these to know what works for me, but it's good to know there are alternatives. Some member U1C such that. So then U is open because it's an open cover. Okay. Oh, we're not even using the ball itself to be the finite cover. We're using the ball to figure out where the U is that covers everything else. Okay. God. This one's a lot, but I feel like I made much more progress understanding this than I thought I would. I guess I did kind of skip over this lemma. What was the original purpose of me doing this again? So wait, I was looking at that, but I was looking at this because I was looking at this. So this might have to be, well, I mean, I guess we could try to look at this. I'm not planning to go for a ton long because section 2 of real analysis is about to start. But we still have a few more minutes. So, okay, all that I was doing there was in the name of understanding what 7 is asking me. Following family of open sets A sub I negative 1 over I comma 1 over I and B sub I equals negative 1 plus okay. Oh, you know, I feel like I kind of was working on these without realizing that I was working on these. Well, it wasn't even the same numbers, but where am I going to put this? I'll put it up there. It's going to look kind of bad, but who cares? I guess we'll just scroll down. Okay, so I mean, honestly, actually, I don't need to even show that in the first place. Because I'm going to take a screenshot of it and put it in the actual Paint document. Okay, Paint. Okay. Why is A sub I an open cover for negative 1, 1? Well, I guess what's happening with this is How should I do this? I like one interval like starts at -1 and gets closer to 0. The other end starts at +1 and gets closer to 0. So it's really only an open cover because of these starting points. As far as I can tell. At least how I'm interpreting this. Ugh, okay, fine. Oh wait, I'm not showing my paint. Oops. My bad. Explain why B sub I is an open cover for -1, 1. Oh, okay. There have been typos in this before, so I appreciate you being on the lookout. So you're gonna start, this one starts from -0.5 and gets closer to -1. And the upper end starts from +0.5 and gets closer to +1, okay? Oh, I guess to make you realize that the difference with B sub I, there's no redundancy in B sub I. It has no finite subcover. And I guess that's what is being hinted at with these two examples before getting to the bigger idea. Of each interval, of each successive interval is closer or approaches -1, and the end point of each successive interval approaches +1. So our answer over in C, -1, 1 is not compact because A sub I, an infinite subcover, or an infinite cover of -1, 1 has a finite subcover, which a compact set cannot allow for. All right. What a freaking journey that turned out to be. Every set of a cover has a finite subcover. Oh wait, did I have that backwards? Every open set has a finite subcover if it is compact. Oops, it's not compact because B sub I has no. Oops. Yeah, I did that backwards. No. Oh, dude. Paint is the worst. Cook. I'm trying, Ben. I'm actually just about to end things and read out in a minute here, but dude, it's been a freaking journey of doing math that I'm not comfortable with, but still managing to kind of learn it. Oh my god, I'm writing this wrong. I have the idea though. I had freaking. I'm sure Zach is probably live already. Let me actually look. Yeah, okay. Zach is live, so let's go raid out. Things with German has been hanging out with me. Actually, I'm gonna end things on YouTube. I forgot to do that. All right, goodbye YouTube. I appreciate you all, whether you're chatting or lurking. I'll be back with math on a Saturday.